A confirmation about the audio, please, guys. If the audio is clear and available. Thank you. So, Lakshana, basically for the prelims 2024, ideally you should be concentrating upon the portions of climatology, the physical geography portion that we are studying. Concentrate on that. And then, along with that, as we move on into the portion of Indian geography today, I would suggest to you that take a look at the portion of the current affairs development as well, the portions which you have been going through the current affairs for the past 1 year. So take a look at the important places in news, the important topics in news. And then after that, do take up the prelims test series. The prelims test series is about to be launched. So do take up these prelims test series very diligently. And don't worry if a question is something which you don't know. Think about it, that if, let's suppose, you don't know a particular answer, then think about that particular thing as, or the explanation of it as, a new content source, and keep on adding to your knowledge arsenal, and automatically, slowly and steadily, you will improve. But you need to get into the habit of practicing as many prelims test series as possible. Now, Sham, so you told that salinity decreases from while going from equator to poleward, but at higher latitude, generally salinity is high due to low evaporation. No, low evaporation and low precipitation, and due to freezing of ice, salinity is high. No, see, low evaporation will never lead to high salinity. First of all, understand that. And in the higher latitudes, you also have the factor of melting of ice. So due to that factor of melting of ice, again, the salinity levels decrease. Understand, the salinity levels, whatever they are in the polar region, no way will they have the level of evaporation as compared to the equator. So salinity levels at the equator is generally high. It is the highest in the tropics, but the general trend of salinity is that of a declining one from the equator to the region of the poles, with an aberration at the region of the tropics. Okay, and there also there is a slight difference in terms of salinity levels around the Arctic and around the Antarctic region, where in the region around Arctic, still you will have some amount of evaporation, some amount of salinity caused. But there is a huge seasonal variation in the Arctic region due to melting and refreezing of ice. Okay, so there is no contradiction in that part. Salinity is determining the portion of density. What is density? Density is basically, Afrin, how closely the particles are closed, or how closely the particles are with respect to each other. So any material, when we say that the density is high, that means the particles are very closely placed with each other. So if a salinity is high in 1 kg of water, that means in 1 kg of water you have more salt content. That means in that 1 kg of water, as compared to any other water sample which has lower salinity, there will be more number of particles in that 1 kg. Hence, there will be a greater amount of aspect of density. Mohan, my dear friend, what are the portions in human geography? Are we aware of that? Don't worry. As we move ahead, and by the time that we complete the entirety of the modules, human geography, economic geography, all of that, Indian geography, everything will be covered duly well by the time that we are done with the completion of the syllabus. Don't get swayed by these terms that this portion is left, that portion is left. Just complete the module, and after that, you will be able to analyze that, okay, economic geography has also been completed, human geography has also been completed, and you will understand that. Okay, the many of the candidates, when they start the preparation, they are swayed by so many terms. Biogeography, there is world geography, there is physical geography, there is Indian geography. Now human geography and economic geography is very much a part of the physical geography, of Indian geography, that we are going to study. Okay, lake can have highest salinity. Depends upon which lake are we talking about. If we talk about Caspian Sea, for example, it is also a very large lake. Now, that Caspian Sea basically will have a very high salinity level in the southern part, but in the northern part where River Volga drains into the Caspian, it will have low salinity. Then take a case of Baikal Lake. It has got very low salinity, right? So it is not always the case depending upon the location of the lake. It is just that Lake Van is one of those which has got the highest salinity. Yes, that we had discussed yesterday. So yesterday, basically, we have had a discussion about the portion of the in terms of the ocean temperature. We discussed how is it that the oceanic temperature varies from one area to another. We discussed about ocean salinity. We discussed about the horizontal and the vertical variation in terms of temperature as well as salinity. We understood what is the concept of a thermocline. Thermocline is that layer at the depth where the temperature does decrease quite drastically. And then we discussed about the concept of the halocline also, where we discussed that as we move away from the surface, as we move into the depth, there's a variation in terms of salinity levels there also. So there we observed that basically as you move into the depth, at a particular depth, you will have a variation in terms of the salinity, where at the bottom, salinity of the oceans is always consistent around 35 parts per thousand. So whatever is the surface variation, in the tropics, the surface salinity can be 36, 37 parts per thousand, right? In the equator, it can be around 35 parts per thousand. In the higher latitudes, it is much lower, around 34, 33 parts per thousand. Now, all of them basically will have a kind of a confluence, a kind of a uniformity at a particular depth at the base, where the salinity levels will be roughly around somewhere 35 parts per thousand. Now, after that, we had started the discussion around thermohaline circulation. We discussed that how, due to the factor of density, you can have a different kind of a circulation initiated, where in the lower latitudes the water gets heated up, it expands, and then it starts moving towards the region of the higher latitude. And as that water movement from the lower latitude to the higher latitude happens, the water, when it reaches the higher latitude, it cools down, increasing its density. At the same time, there is some freezing action, and freezing action again increases the salinity. So colder water, high salinity, always the water density will be so high, it will start to sink. So that is the case that you will come across, and that is what fuels in a kind of a thermohaline circulation. Then we discussed about the wave motion, where we discussed that the waves can be initiated by the movement of the winds. And when the winds blow over, they carry some amount of water, and but that water is then recirculated back. So there is a kind of a circular oscillatory motion for the water particles in the case of a wave formation. Now, when the wave comes on shore, that is what is referred to as a swash. And every time that a wave comes on shore, the wave basically washes back and moves back again. So that movement of the wave going back to the sea, that is referred to as backwash. Then we had initiated the discussion about the occurrence of tides, where we observed that the formation of tides is basically the vertical variation in terms of the height of the water. Now, that vertical variation in height of the water is generated because of two different forces: gravitational force of the sun and the moon, and also due to the aspect of the centrifugal force. Now, we had discussed when we talk about the gravitational pull. Now, even though sun is much more massive, has got a greater mass, but because sun is very far away, it is the gravitational pull of moon which is the more dominant factor, and the gravitational pull of moon which influences the bulge, the tidal bulge which gets created. There we also saw that, for example, when we talk about the gravitational pull of the moon, let's suppose we consider the planet and the oceans. Now, while the gravitational pull is nowhere as strong to be able to pull the continents and the land masses towards itself, but then the oceanic water can definitely be pulled due to the force of gravitation. So if the moon, let's suppose, is here, then it will develop a bulge towards the direction of the moon. The water will develop a kind of a bulge towards the portion of the moon. But yes. Now, that bulge will be developed how? By getting water from these areas. By getting water from these areas, that water will be supporting that tidal bulge. Otherwise, where will that excess water come from? Isn't it? That is why this bulge which is created is where the seawater will rise higher, right? The seawater level will increase higher temporarily. Now, the planet is a rotating object where the momentum of the planet is always conserved. That is how the planet is able to maintain the rotation and revolution as well. Now, in order to conserve the momentum, when the planet has developed a bulge on this side, there will be a counter bulge developing on the other side as well. There will be a kind of a counter bulge developing on the other side also, right? So these two places will experience high tide, because there is a bulge there, right? So there is a rise in water level. So these will experience high tide. Whereas when we talk about these areas where the water has actually moved out in order to support the high tide, these will be the regions of low tide conditions. Okay. Now, as the planet keeps on rotating, let's suppose the position of the moon comes somewhere here. It comes somewhere here. Now, in that case, the bulge will be supported here towards the portion of the moon. Right? There will be that shift in the tidal bulge. Again, as the planet rotates, let's suppose the position of the moon is here. So this region will experience a tidal bulge. So the opposite region will also have that bulge created. So like that, different places in one complete rotation of the planet, places will generally experience two such tidal bulges, where you will have two cases or two instances of high tide, and you will have two such instances of low tide as the planet rotates around its axis. So here, as the planet moves, as the planet rotates on its axis, two places or any place generally will experience two instances of high tide and two instances of low tide also. This is the general scenario. That is generally. Okay. In most of the circumstances, this is something that you will observe. So how do you observe it on the ground surface? Kuraku is basically you observe the sea level if you are, let's suppose, in any of the coastlines across the country. If you have been on a coastline across the country, any coastline, you would have basically observed that at around 1:30, at around, let's suppose, 2 p.m., if this is 1:30, 2:30 p.m., it is around that period of time. So if, let's suppose, at that point of time, if you consider this to be the coastline, if this is the water level, normal, average water level. Now, in this case, if this is the average water level, then basically during the high tide, the water level will rise ever so slightly. Okay. Now, how do you get to feel it? So basically, water will come slightly further inland. During the conditions of a high tide, water will come ever so slightly inland. That is why as you go to the coastal areas, you will find places near the beach gets flooded during the night, right? And again, during the morning, water basically retreats. Then, during the conditions of a low tide, water level will come slightly down. So, this is what is also referred to as the high tide line or HTL, high tide line, or what is also referred to as HTL. This is what is regarded as the low tide line or the LTL, right? So, and this particular portion between the high tide and the low tide, this is what is regarded as the intertidal zone. Intertidal zone. Generally, you will find the presence of mangroves and other such kind of a vegetation in the region of intertidal zone. That is why construction is never allowed in the areas of intertidal zone, because it is considered to be a region of critical ecosystem and critical habitat also. Okay. Is it uniform in all places on the earth? Absolutely not. It is not going to be uniform in all places of the earth. Because apply your logic here, think about it, that water is getting, suppose there is a high tide here. Now water is getting supported from these areas to supply to the region of the high tide. But what if there are land masses in such a way that water is unable to reach there efficiently? So you have some of these areas where you will have this high tide, low tide condition only once. But majority of the areas across the planet will experience high tide twice and low tide twice. But some of the areas, owing to the location of the land masses around them, they are able to support high tide or low tide only once. Okay, that tidal variation is supported only once. Now, there, another factor that you have to understand is the force of the centrifugal force, as we refer to. Centrifugal force of planet Earth is also significantly important in terms of developing a bulge against the portion of gravity, right? So there is, due to the force of gravity, there is a bulge developing on one side. Now the centrifugal force helps to develop the counter bulge. Now what is this centrifugal force? What do we understand by centrifugal force? So any object which moves any object which moves in a kind of a circular motion, it experiences a force towards the center, but simultaneously it also experiences a force away from center. So that force which is experienced away from the center, that is what is referred to as centrifugal force. Force acting away from the center. Now, where do we implement it across the planet? So here, think about it. Let's suppose you have the sun. Let's suppose this is the sun. Now here, let's assume this is the orbit of planet Earth. Let's assume that this is not Saturn and its rings, it is the orbit of planet Earth. And here, let's assume planet Earth is situated here. Okay. Now, the planet Earth, as it moves continuously across its orbit, it is going to experience a centrifugal force, right? This is the sun. As the planet moves across its orbit, it is going to experience an outward centrifugal force. Now, while the centrifugal force which will be acting on the planet will be in this direction, the force that is, let me write it down here, direction of the centrifugal force, of centrifugal force. So here, the direction of the centrifugal force is outwards. Now, while that is nowhere strong enough to basically deviate the planet from its axis, deviate the planet from its position. But nonetheless, this centrifugal force is still significant in order to cause a tidal bulge in the other direction here. So on this side, you will experience a bulge due to the gravitational pull of the sun, and there will be the centrifugal force, which shall develop a counter bulge also. So the final tide formation that you come across is always a sum product of these three forces acting in tandem. It can be against one another or it can be complementary. That is, the gravitational pull of the moon will create a tidal bulge, gravitational pull of the sun will create a tidal bulge, and also the centrifugal force also ends up creating that kind of a tidal bulge. So that is why these three factors are very important and pertinent in order to understand the bulges which get created. By the way, about the few of the previous year questions that we still have to discuss, we have discussed the previous year questions from the portion of climatology. We will be discussing the portions, the previous year questions from the portion of oceanography and Indian geography. Some portion of it we'll try to discuss it together. Otherwise, oceanography, we will be able to discuss the PYQs tomorrow itself. Don't worry about it. Okay, so this is how you have the existence of this centrifugal force. Now here, just to give you an idea, UPSC had actually asked this question once, where UPSC had, or rather twice, I think in prelims UPSC had asked this question, where the question was, which of these forces are responsible for the generation of tide? You had option 1, gravitational force of the moon; option 2, gravitational forces of the sun; option 3, the centrifugal force. Now, eventually, the answer would be all of the above. So, such kind of simplistic questions are oftentimes asked in the prelims exam. Now, this is a kind of a schematic to help simplify and help you understand the impact of these forces. So, when we talk about the sun and the moon, they will have their own tidal bulge. And when we talk about the centrifugal force, there will be a tidal bulge of the centrifugal force as well. The balance of both of them will represent a tidal bulge on both sides. And that is where you have the tidal bulges which are created on both sides. And these are the regions of high tide. These are the regions of high tide. And from here, water moves to these areas to support that high tide. So here you will have the conditions of low tide. Here also, low tide conditions. Right. Now, even for that matter, I don't know if you are following the portion of current affairs, if you are following the cyclone Michong. I hope you are following the news moving around cyclone Michong. Now, that cyclone Michong, which has come into existence, there is a coastal flooding and storm surge which has been created. We have studied about storm surge, we have studied about the cyclone. And remember, we had also discussed that the next cyclone is going to be named Michong based upon that list. And we had also discussed further on. Now, there you would have observed that while Chennai has been flooded, the coastal areas of the Chennai region of Chennai have been flooded. Significantly more amount of flooding in Chennai was initiated yesterday after the noon high tide. That is, after the high tide conditions in the noon, when already the water level was slightly higher, and then you had a storm surge, what is also referred to as the tidal wave action of the storm surge, which accelerated the flooding. Even last night, Chennai, further more areas got flooded, and today something similar is expected to happen across the region of Andhra Pradesh coastline. Okay. Now, after this, here we come to the classification of the tides. Classification of the tides based upon sun, earth, and moon position. Aditya, even Indonesia also would. So I hope that now you have studied those basic portions. You don't find it difficult in order to follow these portions of current affairs. And I hope that when you're reading these news stories, you have a feeling of being well aware and slight feeling of satisfaction that at least one of the unknown factors in my entire knowledge arsenal is solved. Slowly and steadily, like that, as you cover the entirety of the basic static portions, very soon you shall be in a position where any kind of news story that you come across, you will be able to predict what has happened and what is going to happen in the future. So that is how, that is the purpose of the static portions. That is why UPSC wants you to study these static portions, so you can understand the developments happening around. Nonetheless, now when we talk about the classification of the tides, one of the primary classification of the tide is basically based upon the position of the sun, earth, and the moon. Now, what kind of classification do we have, or what kind of different conditions do we experience? So whenever we have the situation where the sun, the moon, and the planet earth, they are in the same axis, they are in the similar axis. It might not be an eclipse, it can be an eclipse position also, but when they are in the same position or the same line, then what happens? Let us understand that. Which part of lecture contains cyclone chapter? My dear friend, the portion of climatology. But rather than directly looking into the portion of cyclone, I would rather suggest to you, study the portion of climatology in detail, then study the portion of cyclone, then it will make some sense. Otherwise, that kind of a shallow information even newspapers are able to provide you, that low pressure was created, low pressure led to the cyclone formation. If you want to really understand the portion of the formation, always start from the basics, and then you will be able to understand. Other than that, I won't be able to help you out significantly in this. Now, here, if you take a look at the position of the sun, observe here, first of all, observe here the bulge which is created, this smaller one. I hope you are able to see in the image. Now, this smaller bulge which is created is the tidal bulge created due to the sun, due to the gravitational pull of the sun. Now, if the moon is also on the same axis, then the tidal bulge created by the moon, this is the tidal bulge created by the moon. So, if they are along the same axis, both these tidal bulges, they would basically tend to complement each other. Both these tidal bulges will complement each other. So, as a consequence of that, what will you experience? Here, you will experience that both these tidal bulges have added on to each other. Now, by the way, when the sun, the moon, and the planet Earth, they are in the same axis, that position is known as position of Suzuki. There also, when the moon and the sun, they are on the same side of Earth, that is the position which is referred to as conjunction. When the moon is opposite to that of the Earth, Earth is in between the moon and the sun, that is referred to as opposition. So Suzuki has got two positions. Suzuki is due to, it has got two positions, conjunction and opposition. Is Philippines earthquake reason for Michong? How? How did you convince yourself that Philippines earthquake can be a reason for Michong? I would like to understand that aspect of your thinking. So let me know, how do you think that of an earthquake in the region of Western Pacific, how can it initiate a tropical cyclone in the region of Bay of Bengal? Let me know about your thinking. I would be very, very interested to know. Now here, when we talk about this particular position of conjunction or opposition, what do we observe? That the tidal bulge of both these, tidal bulge created by both these, they tend to complement each other. They tend to complement each other. So here, what you will have, this is a condition of a high tide. High tide will be higher than normal, will be normal, or will it be lower than normal? What do you think? What is the condition of the high tide in this case? Will it be higher than normal? Will it be at a normal position, or will it be lower than normal? Good, very good. Higher than average. What about the conditions of a low tide? Low tide, will it be higher than normal, or will it be lower than normal? Very good, beautiful. Because all that water will be used in order to support the higher level of high tide. So low tide will also be lower than normal. So both of these conditions, when they are experienced, this is the condition of a spring tide. Both of these are because of the conditions, or both of these are referred to as the conditions of spring tide. Now here, moon takes close to around how many days to complete one movement around the planet Earth? What is the time consumed by moon to complete one movement around the Earth? Around 28 days, isn't it? Dhyan, conjunction is when moon and the sun are on the same side. Opposition is when the moon is to the opposite. I'll give you the written portion of it also, don't worry. So here, generally, the time taken by moon to complete one rotation, one movement around the Earth, and also one rotation around itself, is around 28 days. It takes the moon close to around 28 days to complete one movement. So what will be the time taken for the moon to move from here all the way till here? What will be the time taken? Easy. 14 days, right? So we can say that spring tides, they repeat themselves every 14 days. Every 14 days, you will have a condition where the normal high tides that you experience, they get higher than normal. And the low tide condition will also be lower than normal. Then you have when the moon is located in a different position, when the moon is actually perpendicular to the axis of the earth and the sun. So when the moon is perpendicular to the axis of earth and the sun, this is position which is also referred to as quadrature. That is what is also referred to as quadrature. Now, in the conditions or in the position of quadrature, what do you observe? What do you experience? You will observe basically that look at the solar and the lunar bulge again. The bulge created due to the sun and the bulge created due to the moon. This is the bulge created by the sun, which is very similar from the earlier situation. It is almost same as the earlier condition. But this time, the lunar bulge, rather than supplementing the solar bulge, is in a way counteracting it. Right? So, what do you think will happen? What will be the condition of high tide and low tide? So, the height of the high tide in this case, high tide lower than normal, lower than normal, and then low tide. What will be the condition of low tide? Very good, Karthik. What do you think? Good. Zeba, Chandrajyoti, Purva, Rohit. Very good. Low tide in comparison will be slightly higher than normal. Higher than normal. Okay. So that is the case where in the condition or in the position of quadrature, because the lunar bulge is like this, right? And due to the solar bulge, some amount of water from this area has to be directed to this region. That is why the proportion of high tide will not be that much exaggerated, as is the case with the spring tide. So that is why in this case, the high tide will also be lower than average, because that position of the high tide will be compensated slightly by the low tide position of the sun. As per the sun and the gravitational pull of the sun, here should be a bulge and here should be a deficient area, and that is compensated by the lunar bulge. That is why, as compared to the earlier scenario where both these bulges could complement each other, here they actually compensate or contradict each other. That is the condition of a neap tide. Neap tide. Okay, so that is the case where, I hope, Sahithi, now it is understood. That is the case where, because they are cancelling out each other, they are contradicting each other. That is why the height of the, in the case of the high tide, will not be as high. It will be slightly lower. Whereas when we talk about, if the high tide is lower, think about it. If the high tide is lower, means you don't have that much water coming from the lower areas in order to support it. So the low tide will have slightly greater amount of water. So that is why low tide in comparison is slightly higher than normal. Okay. Gravitational pull of the moon in terms of the tidal impact is always much more stronger as compared to the sun in terms of the tidal impact, right? Why? Not in general scenario. Please don't quote me here in normal scenario that he has said that the moon's gravity is stronger than the sun. But in the book, I have seen this. So either the book is wrong or you are wrong or both are wrong, and give me my merit list. That does not happen. Please understand. I'm telling you in general scenario, the impact of the moon is much greater in terms of influencing these tides as compared to the sun, because the sun is very far away. Regardless of the very high mass, sun is significantly far away. Now here, think about it. What will be the time taken if the moon's position was here? It would have been the condition of a spring tide. Here, in this particular position, the first quarter, that is where you experience neap tide. So the time taken from a spring to a neap tide is how many days? Very good. It will be 7 days. So after every spring tide, after 7 days of every spring tide, you will have a neap tide. Again, after 7 days, you will have a condition of a spring tide. Again, after 7 days, you will experience the conditions of a neap tide. And again, after 7 days, you will experience the condition of a spring tide. So that is how there is a kind of a 7 day interval between each of these scenarios. So here, when we take a look at it, so spring tide, when the sun, the moon, and the earth are in a similar axis, the height of the tide will be higher. They occur twice a month, once during full moon and once during the new moon period. That is when the position of the tide is higher. Okay. Opposition syzygy lead high tide higher than normal and lower tide lower than normal. How they oppose how they oppose direction to each other, clarify, sir. Opposition syzygy lead high tide. So you have understood the portion of conjunction. Shalu, I guess you have understood the position of conjunction, why conjunction will have a high tide. A very similar phenomena is there in a position also. Think about it, break it down. This is the position of the planet Earth. Here you have the moon. So what will be the lunar bulge created in this case? What do you think? The lunar bulge. Lunar bulge created in this case will be like this, isn't it? Now, what if, and the solar bulge also I will indicate, Let's suppose I'm indicating the solar bulge also. Solar bulge is like this. This is the point of conjunction. Let's suppose this is your sun. Now, in case there is a situation of opposition where this is your planet Earth, this is your planet Earth, this is the position of the moon. Now, in this case, what will be the tidal bulge created by the moon here? Tidal bulge created by the moon will be like this. What is the tidal bulge created by the sun? Let's suppose the sun is here. The tidal bulge created by the sun will be like this. So, isn't it the case that in both the situations, the solar and the lunar bulge will add on to each other? Either the moon is on the side of the sun or the moon is opposite to the sun. Won't it be the case that the lunar and the tidal bulge, they will complement each other? So that is something that you experience where the high tides, that is why the high tides will be much higher. And in order to support that high tide, water will be generated from these areas and the low tide will also be lower than normal. Is that understood now? Udesh, is that why fishermen go to deep sea fishing for not more than 7 days? It also has got to do with the aspect of Udesh, the aspect of their food stock supply, etc., and also because of the factor of the tide. Yes, but in the terms of tides, if you want to observe the fishermen, generally you would observe that the fishermen, they leave the shore when around 2 a.m., 3 a.m. in the morning, right? If you have been to the coastline at that point of time, that is when the coast experiences high tide. And that is when they will leave the shore at that point of time. And when do they start coming back? Maybe after 2 days, 3 days, 4 days. When is it that they actually come back? You will never observe the fishermen coming back at 10 a.m. in the morning or 6 p.m. in the evening. No, or 6 a.m. in the morning. No, you will observe them to come back around 1, 2, 3 p.m. around that point of time in the afternoon. Again, why? Because when you have the conditions of a high tide, water comes further inland, right? If I have to use this image again. So generally you will observe that they will park their boat somewhere here, right? Now when the conditions of high tides prevail, that is where they use the tides in order to have an easy movement. And again, when the low tide comes, that is when they are already at sea. But again, when they have to return back, they want to park their boat somewhere here, not drag the boat all the way from here to here. So that is why, again, during the high tide conditions, you'll find them returning. But in general, that is the scenario where they generally pace it up in such a way that you have a 7 day interval between them, because understand that this tidal effect, this tidal movement also has the impact in terms of the life in the coastal areas when it comes to the conditions of a full moon night. Now in the conditions of a full moon night, the intertidal zone is teeming with life. So in the exact coastal areas closer to the shoreline, you will have greater amount of fish catch also. So that is basically what you will observe as a different phenomena of the marine biology. You will experience that the fishermen are well attuned to that. They might not know the details of it, the scientific backing of it, but they know the phenomena, how it plays out. What is the importance of tides? Tides have got some importance, but more than that, you have to understand that it is a natural phenomena. It is a very kind of a natural phenomena. Now, when the sun, moon, and the earth are in the similar line, the position is known as syzygy. And this syzygy can be of two types: conjunction, when the moon and sun are on the same side, and opposition, when the moon and sun are on the opposite side. So in this case, in this situation, obviously both the lunar and the solar tidal bulge complement each other. Both lunar and solar tidal bulge complement each other, right? So that is why the high tide created is much higher. Hence, high tide created is much higher than average. So basically, whenever you have these conditions of the tides, the high tides, whenever they come, generally you will find it is used for navigation purposes, especially by the boats which are going to the sea. It basically makes them easy. In many of the areas across the world, you will find that across the harbor where the water level is very low, that is where most of the boats they are parked in the region of the harbor. As the water level goes higher, it is easier for the boats to sail back, and that is when they start sailing back into the sea, so that they don't get floored on the ground surface, they don't strike the ground surface. That is why high tides are mostly used for navigation purposes. Okay. Yes, Shazia, that is how they can help the ships also move away from the shore and come towards the shore. Now, this is the spring tide. Now, spring tide is followed by the conditions of neap tide. Now, what is a neap tide? So, there does exist a 7-day interval between the spring tide and the neap tide. The sun and the moon are at right angles to each other, and the forces of the sun and the moon tend to cancel each other out, counteract each other. The moon's attraction, though more than twice as strong as the sun's, is diminished by the counteracting force of the sun's gravitational pull. So they cancel out each other, and hence the level of the high tides is lower than normal quite substantially. Now, when we talk about the characteristics of the tides, the tidal bulges on wide continental shelves have greater height when the shelf area is wide. So the discrepancy created as the water comes in. So that is where the discrepancy created or the aberration created is much higher. What does that mean? That means if let's suppose you consider a region of a very wide continental shelf, significantly wider continental shelf, let's suppose. Now, if this is the level of water here, normally, if this is the level of water, and here you have the end of the shelf or the shelf break. So during the conditions of a high tide, what happens? From around the regions, you have water coming in to support the high tide. So water will come in here. From the around surrounding areas, water will come to support the high tide. But here, because the shelf, which is having less gradient, it is very extensive. So there you will experience that even if the water comes slightly higher up, let's suppose the water level goes higher very so slightly. Now observe the impact on the ground. You will observe that the high tide is able to come much farther inland. It is going to be able to come much further inland. The region Chandipur in Odisha, right? You would have heard about Chandipur. You would have heard about the conditions of or the what is done in Chandipur in terms of defense. Chandipur is important. Are we aware of that? Yes, you have the Kalam Island there. What is done in Kalam Island? Missile testing range. Good. So that is where Chandipur is basically one of your missile testing centers. Now, in Chandipur in Odisha, you have this, the uh, shelf is significantly wide. Now, there you have, due to the surrounding land areas and its dimension also, as the water comes in, the water during the high tide it comes in, it is complemented by the surrounding land area, and water during the low tide as it goes out, again, is impacted by the land shape around it. So in Chandipur, you experience a very unique phenomena where during the conditions of a high tide, water comes to a particular level significantly inland. And during the conditions of the low tide, water goes or withdraws back a few kilometers. Right. So there is the intertidal zone extends for a few kilometers in the case of Chandipur. It is almost a flattish coastline there. That is why you will come across a very unique phenomena where during the low tide, as the water goes back, you have people roaming around and you have all the touristy activities taking place. Touristy activities in the sense the vendors, etc., moving around. And then as soon as the high tide comes, they cover a significant amount of distance altogether. So that is where it basically comes further inland. Okay, right? Now, tidal tidal impact is observed only in the case of the seas and the oceans. Yes. Okay. Can tides be happening in large river like Ganga or Yamuna? Not in Yamuna. But when we talk about River Ganga in itself, not throughout the river, you will never experience it. But right at the point around Sagar Islands, where River Hooghly actually meets out to the sea, at that particular region, you will observe during the conditions of high tide, there is a kind of a backwash of water. So the water level ever so slightly, especially during the storms, you will observe water level ever so slightly goes higher up. And then again, during the conditions of low tide, the normal flow is maintained. So you have slight variation observed right at the mouth of River Ganga, but obviously not in the entire. So rivers are not impacted by this tidal movement. Then here, the shapes of the bays and the estuaries along a coastline can also magnify the intensity of the tide. We have already seen what are estuaries, the regions where the fresh water meets with the saline water of the sea, right? Saline water of the sea comes inland. What is a bay? Bay and gulf. Are we aware about bays and gulfs? What bays and gulfs are? No? You would have at least heard about it, that this is a bay, this is Bay of Bengal, this is uh, the Persian Gulf, etc. Yes, Geeta, you are correct. Generally, when we talk, Ashish, correct. So when we talk about bays and gulfs, these are those indentions across the landmass where water has come and is surrounded by land. Same is the case with the Gulf also. Water is surrounded by land almost on all sides. The difference between a bay and a gulf is that a bay will have a larger opening, the mouth of it will be larger, whereas in the case of a gulf, it will be narrow and it will have a smaller opening. For example, Bay of Bengal, wider opening, Hudson Bay, much wider. But when you consider, for example, Persian Gulf, very narrow, right? Gulf of Mexico is one of the largest gulfs to exist. Now, the shape of the bays and the gulfs also will fuel in more water to come in or more water to exit out. For example, one of the highest tidal variations that you observe is observed in Bay of Fundy. One of the highest tidal variations. Locate the region of Bay of Fundy. Observed is in Bay of Fundy. Bay of Fundy, I'll give you the hint, is situated across the eastern coast of North America. That is where, and what I want you to do is, please don't have that school mentality, school kid mentality, where as long as when I say locate, you locate that, and then you feel a champion that he had given me a task to locate Bay of Fundy. I could do it in 5 minutes. What is he talking about? I am the actual champion. Please don't have that mentality. When you observe that location, notice it. That what are the regions around it? You will find it is so closely surrounded by land. It is a kind of a narrow inlet which is provided, and that is where the influence of the water coming in is so high that during the condition of a high tide, there will be much significant amount of rise of water. Okay. Now, when the tide is channeled between the islands into bays and estuaries, they are referred to as tidal currents. So, for example, let's suppose here, let's suppose you have one of the islands in this area and the land here in this region. Let's suppose this is the condition. Now, during the case of this is your sea, this is your land. During the conditions of a high tide, when the water level goes higher up, that water will be pushed in here also, isn't it? In general, the level of the sea goes higher up slightly, so it will be pushed in. Now, that pushing in which has happened will be moving with a certain speed, and that is what is a tidal current. Again, when you will have a conditions of a low tide, whenever you will have a condition of a low tide, what do you experience? That the sea level goes slightly lower. The sea level will go ever so slightly lower. Now, whatever the higher amount of water would be here, that would rush out, that would rush out towards the sea, isn't it? So that sudden rush of water induced due to the tidal variation, that is what is also referred to as tidal currents. Wherever the seawater gets narrower, or wherever any bay or estuaries they get narrower, that is where the impact of this is much more magnified and it is felt in an exorbitant manner. Okay, so that is the information that would suffice for the examination perspective as far as the tides are concerned. Okay. If the statement comes in PT 24 tide only impacts ocean and sea, will it be right? It will be right. It will be right, always. So when you hear about the tidal energy, that we are generating energy with the help of the tides, it is basically these tidal currents which rush in and move out, that is used to rotate the fans, a kind of a turbine set which has got those fin-like fans in the lower portion. So as soon as there is a rush, that starts rotating, right? As there will be a rush back, they will again rotate. The generator is coupled in such a way that in either direction as the fan rotates, the generator rotates in the same manner and it is going to produce electricity. So that is how you produce tidal energy, which is also a form of clean energy. Okay, right? Now, after this, we come to the portion of ocean currents. This is one of the favorite areas of UPSC in terms of oceanography. This is relevant both for your prelims. In prelims, you can expect questions about the forces or factors responsible for ocean currents. Type of ocean currents. Also match the following kind of a question. The following type, where you will observe basically name of ocean current and also ocean where they are situated they are observed, and whether it is a cold or a warm ocean current, that also will be can be asked for. Match the following. In the mains examination, questions which have been repeated both in the GS and the optional area in the mains exam. Questions for both GS and optional has been largely revolving around factors influencing ocean currents. Okay. Can we draw the ocean currents on answer sheet? Absolutely, yes. You have to. If a question in the mains comes, you have to draw. Rivers like Matla, Vidyadhari, Ichamati, and many more flow in Sundarban experience tide. It is only in the mouth of the rivers where they will experience some slight tidal variation, Shubhankar. Okay, if you think about, let's suppose, a river such as Mahanadi. Mahanadi will originate near Sihava region of Raipur. Now, do you think that in Raipur it will experience a tidal variation? Obviously not. Godavari originates in the region around Nashik. Now, do you think in the region of Nashik it will experience tidal variation? Obviously not. But when we talk about the Godavari Delta, will there be a kind of a tidal variation experienced? Absolutely yes, because that is where it is going to meet the sea. Okay, right? Now, let us talk about what do we mean by ocean currents. So when we talk about ocean currents, what are these? So the ocean waters that we assume, that we see, now it is perceived to be very calm, it is perceived to be very consistent. And basically, when you take a look at the waters in the deep, they appear to be even calmer with slight, even less variations and so on. But then these ocean waters, they move. They do move across very large distances. They do move across significantly large distances in a set direction and a set pathway. It is not going to be the case that the entire Atlantic from the equator is moving towards the region of Arctic region. No, it will have a unique pathway. And there you will have a continuous movement of water in the said direction where regular flow of water will be observed. Millions and billions of gallons of water, they continue to move on a daily, monthly, and an annual basis in the same direction. So these appear to look like a kind of a river flow in the case of the oceanic water. Just like how the river has got a set pattern, a pathway of flow, that is what is observed even in the case of this ocean currents. Now, these ocean currents were initially discovered. It would be known for a long period of time, but basically initially discovered by the merchants and the marine explorers who observed that when they would reach in a certain part of the ocean, closer to the coastline, obviously, their ships would accelerate. Their ships would be accelerated in a set direction. And he observed that it would be definitely because of the movement in ocean water. And that is where you had the entire ocean currents which were discovered. And all the sailors would report back that where I went, this was the movement observed, where I went, this was the movement observed. And like that, the reportage happened. You had one of the uh, uh, larger ocean currents, Gulf Stream, which was discovered in the 1400s and the early in that point of time by Leon de Pons. At that point of time itself, he discovered the kind of a direction that the oceanic water is going to assume. So these are your ocean currents, which are basically how is it that the oceanic water will move in a certain direction and millions of gallons of water, millions of liters of water will be moving in a similar direction. It is because of multiple forces. It is because of the heating of the sun. It is because of the wind movement. It is because of the Coriolis force. The Coriolis force shapes the kind of a movement, right? The shape of the coastline will also influence the kind of a movement. The bottom relief features of the oceans, they will also influence it. Now, these are your various different forces which end up influencing or shaping the ocean currents. Let us study them in detail. So they are like the river flow in terms of the oceans, where regular volume of water tends to flow in a definite path and direction. Definite path and direction, they will follow that path. They are influenced by two types of forces, namely the primary forces that initiate the movement of water and secondary forces that influence the currents to flow, the shape of the currents, etc. Let us understand them, because the question which is asked and has been asked even last year, you had a direct question in the mains examination which was asked from this topic, that which are the forces which are responsible for the generation of ocean currents, right? You had this question asked in the optional portion the year before that also. And in GS, this has been repeated multiple times. Just like the ring of fire, the Pacific ring of fire has been asked multiple times and the same question has been repeated. Here also, you'll find that the same question has been repeated again and again. So I hope now, Swaroop, you are able to understand the difference between ocean currents and waves. Okay. Divyani, why oceanic water responds to gravitational pull of the sun and the moon? That is because the oceanic water, which is a wide open expanse of water, that will be influenced by the gravity. When we talk about, let's suppose, the river stream, etc., they are very small and small amount of water bodies, so they are almost inconsequential to be impacted by the water, movement of water. By the way, I hope we are aware about the distribution of water across the planet in terms of fresh water and the saline water. That helps us understand how insignificant these rivers are. We might think about these rivers to be the mightiest of the world. We might think about these rivers that, where I live, the river is so wide, people say that it is better than the sea also. The region that I live in, there the river goes so deep, people say that in the lower portion of the river, there might be an ancient kingdom also, something that you don't. So, regardless of whatever myths and folklore that you have heard about or you have seen from your childhood days, rivers are very, very inconsequential as compared to the sea. Just to give you an idea about it, across the globe, if you consider the total amount of water, I'll just give you the proportion. Around 97.5% of the water on the planet is contained in the seas and the oceans. 97.5%. That is your saline water, salt water. That consists of the 97.5% of the entire water on the planet. 2.5% is the amount of fresh water. Only 2.5% is the amount of fresh water. Now, where do we get that fresh water from? So, 70%, close to around 69.5% of the fresh water is present in the ice caps and the glaciers and the snow. Close to around 70%. Around 30% of the fresh water across the planet is present in underground aquifers, in between the rocks underground. Around 30%. It is 0.4% of the fresh water which is included in all the rivers, lakes, ponds, all that you consider. It constitutes 0.4% of the fresh water. So think about it. Of all the water present across the planet, only 2.5% is fresh water. Of that minimal 2.5%, only 0.4% is contained in the rivers, lakes, and ponds. So that tells you, and we are talking about very large lakes here also. We are talking, for example, consider the Great Lakes of the US Canada region, consider Victoria, Titicaca, consider the region of uh, the Baikal Lake, Caspian, Aral Sea, all of them, if you include that, it consists only 0.4%. So that tells you how how insignificant you have these rivers. So they will not respond to that gravitational anomaly at all. But when you have the gravitational pull of the sun or the moon, that gravity, because water is fluid, water can get influenced by that gravitational pull of attraction. That is where you will have that water getting pulled towards. And when it is getting pulled towards, from the surrounding region, water will come to basically support that bulge. That is why tides. Okay. Now, okay, your question is different. What is in it that gives response to gravity? What do you think? What do you think is special about the ocean water that it responds to gravity? Even though I just explained it, but I think you have some different answer in your mind. It's salinity. Okay, right. Okay. So you are saying that had that been a fresh water, tidal bulges would not have been created. Is that the case? How that slight amount of variation are measured across the ocean? So it is basically the sea level is always measured with the help of, you have the average sea level which is maintained, which is measured. So in any particular area, as I told you, in the coastal areas, you will experience the sea water to come further inland. If you are in the deep of the sea, you will barely be able to observe that it is a condition of a high tide or a condition of a low tide. It is across the coastal areas where these impacts get exaggerated because of the effect of the continental shelf. Okay, so that is where the impact will get exaggerated. If you go into the middle of the sea, there, if the water is rising up slightly or reducing slightly, you will never feel the difference. Okay. And Divyani, regardless of whatever your preconceived notion is, understand, if you have had that, if let's suppose you had that kind of a large expanse of fresh water, it would also have experienced a tidal bulge. Tidal bulge has got nothing to do with salinity, my dear friend, right? It is not the case that it is the salt which gets attracted. If that would have been the case, why isn't it that in the desert areas all the sand is getting attracted? Why isn't the case that in the desert areas the sand dunes, they go higher up and come down? So it is not the case. Regardless of what the preconceived notion is, the density of, for example, if you consider, let's suppose in the region of the Arctic. Now, in seasons when you have melting of ice, the salinity sometimes reduces to value of 0. Can you think about it? That the salinity of water reduces to around 0. Now, can we say that in those conditions when the ice is melting, the region of Arctic will not observe any tidal variation? Can we say that? Fresh water will have, the river water will have a greater salinity than the region of Arctic during the season of the melting. Can we say that the river water in that case will experience tidal variation, whereas the Arctic Ocean will not experience tidal variation? Can we have that conclusion? No. So where does the salinity factor come into place there? When we are looking at a scenario where ice is melting across Antarctica, etc., we have seen there those areas. If you don't recall, I will put you back to that particular slide also, where we have discussed that in the Arctic region, that in the estuaries and in those areas, because of the melting and the influx of river water, tidal variation is between 0 to 38, 35. So in certain seasons, the salinity level will be at 0 also. So then what is the reason, in your opinion, which can lead to tidal bulges? Think about it. Let me know. And is there any technology which converts saline water into fresh water? Yes, you have the desalinization plant. Chandrajyoti, yes, it is observed. One of you had said that earthquake in Philippines is responsible for the cyclone Michong. So I'm still waiting for that explanation. And Divyani, I would also want to have your understanding of why you come across the conclusion, or from where did you come across the conclusion that salinity will influence that kind of a tidal variation. These are some of the educational things, let's say. So whenever you come across these newer portions or newer concepts which have the potential to change the world order, you have my mail ID. Please don't hesitate. Send me the mail. We will make a documentary together, and then we will call the Discovery Channel, and then we might publish a research paper also. And Dinesh, sorry, sir, it was due to the Great Depression created. What is that Great Depression created in Bay of Bengal, Dinesh? What do you understand by Great Depression? Do you think there will be a hole created? It is low pressure. Please don't get swayed by these terms, Great Depression and so on. It is the absolute low pressure. Okay, right? Does this shifting of ITCZ have a role to play in the development of Cyclone Michong? Funny, absolutely yes. Remember, while we're studying about the Indian climate, we talked about the fact that in terms of the Indian monsoon, we discussed that the ITCZ moves higher up and the ITCZ moves lower down. So this is the time when the ITCZ partially lies over the Bay of Bengal, and that is where it is the cyclone season in Bay of Bengal. Okay. How can you relate an earthquake with a cyclone? My dear friend, I'm not doing that. I'm not relating a cyclone with an earthquake. I'm just interested to know that how people are relating that. Okay, and I sincerely don't have the mental capacity to do that. And again, I would rather take it as a word of caution, because uh, take it as a word of caution, even the subject matter experts who are very well aware about the subject, who are very knowledgeable about the subject, and any of your seniors, you will also be adhering to the fact. Nowadays, in the era of social media, where you have the era of information given to you through the reels of Instagram and YouTube shorts, where almost any individual and every individual gets on those YouTube shorts, and they will tell you the reason for a geographical phenomena. Always take it with a pinch of salt. If you consider that to be correct, please always verify it with some book or the other. Okay, or some portion of the book, some portion of the text, maybe a research paper, maybe a new research paper, but is that research paper backed enough? So only after that form a conclusion, because otherwise it can lead to significant misconception about many of the larger concepts, right? Many of the larger concepts. For example, I had, and I'm not kidding here, I had one of the students who wrote a series of emails that you are not able to explain the basic fundamental of Mount Kailash. You are saying that those mountains are formed by the folding, but Mount Kailash has been there ever since the evolution of planet Earth, and Mount Kailash is the center of planet Earth. When I ask that person, initially I tend to ignore these things, that this is a kind of a misinformation which automatically will get corrected with time. But when that person was very serious, I asked him about the source, and I was given a source or a link of a YouTube shorts by a random individual on YouTube. So please, there are chances of misinformation. There are multiple good informations which are also given, but always try to verify it. Okay, then move ahead. Is Philippines earthquake due to Marapi volcano's explosion? Where is the region of Marapi? Where is the region of Philippines? Take a look on the map and then think about it. Philippines earthquake around the region of the Mindanao province has taken place because of the subduction of the Pacific plate. The Mindanao region of Philippines is the area where you have volcanic eruptions also, and that is because of the subduction of the Pacific plate. The Pacific plate is subducting underneath that in the region around Mariana Trench, and that is where you have the frequent occurrence of earthquakes and the frequent occurrence of volcanoes. The entire subduction zone extends all the way from Japan and eventually extending till the region of the Tonga Islands in South Pacific. That is why in the entire area you experience that. Okay? Now, difference between a current and a stream is basically that of a speed, the speed variation, the amount of water carried from one region to another. Now we come to the forces that influences the ocean currents. Now, When we talk about the forces which influence the ocean current, primarily, why is it that the ocean currents happen? So, one of the main forces is the heating by the solar energy, the solar insolation. As we discussed yesterday, also, that's in the case of the thermohaline circulation, that whenever you have a high amount of solar insolation, the water tends to expand. There's a thermal expansion. The water gets heated, tends to expand. So it causes the water to expand and results in almost around 8 centimeter higher level of at equator compared to the mid latitudes. Now there is a gradient which is provided. Now this gradient allows the water to move towards the middle and the higher latitude. But it won't be the case that across the entirety of the Atlantic or the entirety of the Pacific, you will have movement of water from equator. All of that saline water is moving towards the region of the poles. That does not happen. So there is a bulge, there is an excess. But then what will be the movement, the direction of movement? So that direction of movement is initiated by the winds, right? So that wind, which wind are we talking about? We are talking about the permanent wind system. So here we are talking about permanent wind system, right? This wind system will shape the movement. How? Let us think about it. Let us think about it. Here, if this is the region of equator, let us consider the region of the Atlantic. Now here you will have a bulge, here you will have a bulge, right? A kind of a slight expansion of water due to heating. Now here you will have the trade winds in place. The trade winds will be in place. So automatically the water will be carried in this direction. It will initially be carried like this, shaped by the coastline and the Coriolis force. This will be the shape of the movement of water. Okay. Now after that, the wind direction and the Coriolis force picks over. But just to justify this point, just to cement this point further, I want you to observe this image again. Observe the region around Atlantic Ocean, the equatorial portion of Atlantic. Now here you would observe something quite unique. Observe here that water, the warm water, what is the shape in which the warm water is present? It is like this. Now why do you think warm water is present like this? Again, if you take a look at the image with your fresh eyes, you will be able to observe a kind of a motion of water like this, isn't it? That is your ocean current which is generated, where the slight amount of bulge created due to solar insolation is then carried over by the trade winds and influenced by the shape of the coastline also. Okay, similarly here also observe, it appears as if water is being carried away in other direction. So that is basically the case how the forces, they will be able to direct these ocean currents significantly. Okay, so this is basically one of the prime factors. Then after that comes the role played by Coriolis force. Now what is this Coriolis force? We have seen earlier, any object moving freely in the northern hemisphere due to the rotation of planet on its axis, it tends to bend to its right. Any object moving freely in the southern hemisphere due to the rotation of planet on its axis tend to bend to the left. So that also shapes the direction taken by the ocean current, right? Shapes the direction followed by the ocean current. Followed by ocean currents. So here, if you think about it, In the northern hemisphere, generally you will find that the ocean currents are such that as the oceanic water moves, it will always bend to the right under the influence of the Coriolis force. It will always bend to the right. In the southern hemisphere, it will always be bending to the left. So that is why majority of the oceanic circulations that you observe, that is the ocean currents that you observe, the system of the ocean currents that you observe in the northern hemisphere, they will appear to be in a clockwise manner, and the ocean currents in the southern hemisphere will appear to be in anti-clockwise manner. Barring, this is a common feature in all the oceans except the northern Indian Ocean. Northern Indian Ocean is an exception. Northern Indian Ocean is an exception because unlike the Atlantic and the Pacific, the northern part of Indian Ocean is closed by land masses. It is almost absent there, isn't it? Atlantic and Pacific are open in the north and south. Indian Ocean is open in the south, but in the north it is immediately above equator that by the time that you reach Tropic of Cancer, northern Indian Ocean is done away with. So because the northern Indian Ocean is so closely surrounded by land mass, there the influence of wind is much more exaggerated. That is where the circulation, the oceanic current circulation, is very much dependent upon the proximity of the landmass. When we come to the portion of the ocean current in northern Indian Ocean, we'll again re-emphasize on the fact. But here, you have to talk about the fact. You can talk about this also. Impact in shaping the currents are much more magnified when closely surrounded by land. Land. Example, northern Indian Ocean. Okay? Any doubts up till this point? Any kind of doubt? No. Good. Now, there are other certain set of factors which will also influence the direction and the shape that the ocean currents take. One of them is the shape of the coastline. Shape of the coastline will influence the direction in which the ocean currents move. For example, again, if I can take you back to that same slide here, it is the shape of the coastline in this area. The shape of the coastline here, which directs the water in the southward direction. It is the shape of the coastline here, which directs the water in this direction. So that directionality is provided due to the shape that the coastline has. Okay, so that is significantly relevant. Here, as the water comes, some amount of water is directed towards the region of Gulf of Mexico. It comes out. It combines with the water from here. And again, owing to the shape of the coastline and also the wind pattern and also the Coriolis force, then the ocean currents take a different direction altogether. Okay, so that is the situation of the shape of the coastline. It basically influences the direction that they take. You have another minor factor, and that minor factor is basically ocean bottom relief. Ocean bottom relief, for example, mid-ocean ridges, etc. Example, mid-oceanic ridges. Yes, correct, Aditya. Now, how will they influence? So, imagine if this is the level of water. Here you have the presence of these mid-oceanic ridges, let's suppose. Now, here, if you have the movement of water happening in this direction, obviously the water will encounter this obstruction and the water eventually will get diverged or diverted because of that. Here also, if you observe the mid-Atlantic ridge, around the region of the mid-Atlantic ridge, that is where Iceland is. Here you have a portion of the mid-oceanic ridge in the form of, here, you have the Weivel-Thomson ridge, right? So Weivel-Thomson ridge, basically, which is a part of the mid-Atlantic ridge, Weivel-Thomson ridge, which is a part of mid-Atlantic ridge tends to trifurcate the ocean current, that is the North Atlantic drift, into multiple parts. Drift into different substreams. This is your Weivel-Thomson ridge feature that you will come across. Rickian's ridge is slightly to the north, Satyam. It is the Weivel-Thomson which comes there. Rickian's is slightly to the north of it. Okay. Trifurcation is further, basically, Rishika, is exaggerated by the presence of Iceland, British Isles, Bay of Biscay in this area, the North Sea in this area, the Norwegian region. So it is also the shape of the coastline along with the portion of the mid-Atlantic ridge here, which offers that obstruction, and that basically divides that ocean current. Okay. Now we take a look at the characteristics of the current, few of the characteristics of the current. So they are strongest near the surface and may attain speeds at over 5 knots at depth. Currents are generally slow with a speed of around only 0.5 knots. Okay, knots is a speed, is a unit of speed. Even for example, when you fly, the speed is always, in terms of the aviation parlance, they will always measure it in knots. When the ships move, they will also always measure it in knots. So basically, when we talk about these ocean currents, most of them are a surface phenomena where, due to the wind action, the solar influence, etc., the movement will be observed on the surface. Now, if water on the surface is moving, it will be able to drag the subsurface water a bit. It will be able to drag the lower portion of the water even furthermore, slightly. So that is where you will observe that as you go across to the depth, the movement observed by these currents are going to reduce. That is why movement of ocean currents at the depth is quite slow. Now you have the type of ocean currents based on the depth, right? Surface currents and the deep water currents. The deep water currents are initiated by the thermohaline circulation that we studied yesterday, where the water tends to move from higher to lower latitudes underwater at a deeper level. But the surface currents that we talk about, they cover only 10% of all the water above 400 meter. That's it. Only 10% of that. But majority of the water lies below it, where you have thermohaline circulations regularly happening, carrying water from one region to another. Right? So this is one of the classification. Then we'll come to the classification based on temperature, etc. We'll talk about warm and cold ocean currents. But before that, we'll take a break. So we take a break for around 10 minutes and we'll be back at 7:55. Let's take a break and let's be back. A confirmation about the audio, please, if the audio is clear. Thank you. Classification of ocean currents based on temperature. So, based upon temperature, we divide the ocean current into either the cold ocean current or a warm ocean current. Now, when do we say that an ocean current is warm or an ocean current is cold? On what basis do we come to that conclusion? So it is not the case of an absolute temperature, that if the temperature is lower than 15 degree or 10 degree, then it will be cold. If the temperature is higher than 25 or 18 or 30, then it will be warm. It is the aspect of relative temperature comparison that you do. That is, if any ocean current which reaches an area, if it is warmer than the surrounding water, it is considered to be a warm ocean current. If an ocean current reaches an area and it is colder than the surrounding water, it is considered to be a cold ocean current. Okay, always that will be the case, right? So that is why you will generally find a scenario that ocean currents carrying water from higher to lower latitude will bring colder waters, because we know that in higher latitude the temperature of water is lower. We do know that near the region of equator and the tropics the temperature of water is higher, isn't it? So generally you will find that when whichever ocean current brings water from higher to lower latitude, they will be bringing water which is colder, right? So I will depict it furthermore in the case of this image also, so that you are able to visualize. So ocean current and its classification based on temperature is the fact that the current and its temperature, the temperature of the ocean water. Let's suppose you have an ocean current like this. Now, this particular portion of ocean water, its temperature in comparison with the surrounding, that will decide whether the current is cold or warm. Generally, when you have oceanic currents carrying water from the lower to the higher latitude, they will bring warm water, isn't it? And generally, if you have an ocean current moving from higher to lower latitude, they are bringing water of this latitude to the lower ones. So generally, it will be colder, right? So generally, you will find, generally, the currents carrying water from higher to lower latitude is considered a cold current. That is considered to be a kind of a cold current. But then imagine a situation, imagine a scenario which actually happens in the case of the Pacific. So here, this is actually which goes on in the region of the, just a moment. Yes, which actually happens in the region of Pacific. So here, when you observe an ocean current moving like this, let's suppose it goes like this, and also a portion of it bifurcates and comes here. Okay, let's name this as A. Let's name this as B. So out of A and B, which one do you think, by the general observation, will be a warm current? Out of A and B, which will be a warm current? What does your logic tell you? Warm current. Why B? Those of you who have said B will be the warm current, why do you think B will be the warm? Basically, understand this again. When we talk about ocean currents and the classification based on the ocean currents, it is not the current's temperature, the ocean current's temperature, which is going to classify it. It is in comparison. So here, let's suppose this one has a temperature of around 15 degrees Celsius. Let's suppose this has got a temperature of 15 degrees Celsius. Now, in the higher latitudes, the temperature can significantly reduce. Let's suppose at this latitude, the ambient sea temperature, the surrounding sea temperature, let's suppose, is around 7 degrees Celsius. But this current is carrying water which has got a temperature of 15 degrees Celsius. Now, in the lower latitude, the temperature here in the lower latitude, average temperature near the tropics is around 24-25 degrees Celsius. Now, this current is bringing water which has got a temperature of 15 degrees Celsius. So, here, A, you will observe that as compared to the surrounding areas, A is bringing warmer waters, right? It is bringing water from lower to higher latitude. And in the case of B, you will observe that it is bringing water from higher to lower. So that is where this will be a cold current. So A will be warm current and B will be cold current. Is this understood? Is this portion clear? Don't accept it as a written fact that, okay, if he's saying so, he might be correct. What alternative do I have? I have already woken up early in the morning, sitting in front of the screen, looking at geography. I could have done many things early in the morning. Don't have that kind of an acceptance. Only if you are convinced why that will be warm or why that will be cold. Is that understood or is there any issue? Yes, Saiti, that is correct. Basically, when we classify the ocean current based upon whether it is the warm current or whether it is a cold current, it is always a comparison that you make, comparative study with the surrounding water. If the surrounding water is colder, then the ocean current is considered to be warm. If the surrounding water is warmer, then the ocean current is considered to be cold, right? Always. Now, for example, this 15 degrees Celsius ocean current that is moving, now some part of it will move to the higher latitudes. Let's say that at higher latitudes, the temperature of the sea is 7 degrees Celsius, but this ocean current is bringing oceanic water of a temperature of 15 degrees Celsius. So in comparison to 7 degrees, obviously 15 degrees Celsius will be warmer current. And here in the tropics, in the region of equator, the surrounding water temperature is 24-25 degrees Celsius. And this current is bringing 15 degrees Celsius water. So it will be the condition of a cold current. So that is why generally you will observe that the currents carrying water from the higher to the lower latitude are considered to be a cold current. This example that I had given, look at this example. This is your North Pacific current. Observe here. Now this gets bifurcated due to the shape of the North American coastline. One portion goes to the north in the form of an Alaska current. Now, Alaska is situated significantly close to the Arctic Circle. So the region around Alaska will be very cold either ways. Now, in that cold area, if you have the water moving in, so it will be warm current. And here, by the way, you have cold water which comes in. So the same water gets divided into two. One is warm and one is cold. One is warm, why? Because it is carrying warmer or water from the lower latitude to the higher latitude. And other is cold, why? Because it is carrying water from higher to the lower latitude. Similarly, here also observe. Wherever you observe water being carried from lower to higher latitude, it will be warm current. Wherever you observe water to be carried from higher to lower latitude, 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 that will be cold current. Okay, so that is a general pattern that you will observe. Wherever water is carried from lower to higher latitude, lower to higher, lower to higher, warm current, lower to higher, warm current. But then higher to lower, cold current, higher to lower, cold current, higher to lower, cold current. So that is where, when we talk about the basic aspect of these ocean currents, so that is basically where you will observe that it is dependent upon the comparative temperature that the surrounding water has. So if the ocean currents, the water brought by the ocean current is warmer than the surrounding, it will be a warm current. If the water brought by the ocean current is colder than the surrounding, it will be considered to be the cold current. So when we talk about these cold currents, they bring cold waters into the warm water areas. Okay, so the water brought by this ocean current is generally colder than the surrounding. This happens mostly when the water is coming from higher to lower latitude. Now, mostly you will find that these cold currents are situated on the west coast of the continents in the low and middle latitude. West coast of the continents, generally. Why? That is because when we talk about these continents, let's suppose this is a continent in the low to mid latitude. So here, as you observe the movement of the trade winds, what will happen to the sea surface temperature at the west coast? Will the sea surface temperature rise up, or will the sea surface temperature reduce? What do you think? As the trade winds are moving like this is your west coast, this is your east coast. So the sea surface temperature here, will it rise up or will it reduce? Beautiful. It will reduce. Why will it reduce? Why will the sea surface temperature here reduce? This is your land, by the way, if you are getting confused. It will reduce because of upwelling, because the surface water will be carried away and the lower subsurface water will rise up. So across the west coast of the continents in the lower to mid latitude, you will find upwelling in action, and that is why you will have colder waters. So the current moving through that area will have those colder waters moving in. So they are usually found on the west coast of the continents in the low and mid latitudes. Warm currents. Here, the water brought by the current is warmer as compared to the surrounding water temperature. Water brought by the current is warmer than the surrounding. Okay, so generally, currents moving from lower latitudes to higher latitudes. Generally, currents moving from lower to higher latitudes are considered to be warm currents. Now, it will be found in the low and mid latitude across the eastern margin of the continents. Across the eastern coast of the continents in low and mid latitude, again the same phenomena. Let's suppose you consider any of the continent. Let's suppose you consider a landmass like this. This is your land. Now, across the east coast, this is your east coast. Here you will have these trade winds, which will blow. Now, they will cause downwelling in this area. And downwelling always tends to increase the sea surface temperature. So that is why, due to downwelling, there will be warmer water across the east coast. And that is why generally the water movement in this area will be that of a warm current. So that is the classification of the ocean current based upon the depth, based upon the temperature, based upon the speed, and so on. Now we move on to the ocean currents in each of these oceans. Now, the additional reading materials, I'm sure many of you have would not have opened additional reading materials till now in your life, and I'm sure many of you would be collecting it. That one fine day when the sun shines vertically, the moon is aligned, and the stars are aligned, and there is a perfect good day. The Santa comes in. That is the day I will pick it up for revision. But whenever you open up that additional reading material, whichever auspicious day you open up the additional reading material, you will find the detailed definitions of all of these ocean currents in that. So that purpose would be solved. Here, I want you to just observe this, understand the mechanism of it, understand the phenomena of ocean current. Because once you understand it for one particular ocean, let's say the Atlantic, you can implement the same phenomena, same mechanism in the portion of the Pacific. You can implement the same mechanism also in the portion of your Indian Ocean. So we will basically cover this portion of the ocean currents in terms of its mechanism. I want you to observe it. And then finally, once that auspicious day comes, when all the stars are aligned and you wake up early in the morning, all feeling fresh and bright, and you open up the additional reading materials and the cosmos doesn't erupt, then you can study about the details of these currents from the additional reading materials also. So, here, when we talk about the Atlantic Ocean, first of all, let us observe the ocean currents in the Atlantic. Now, always, if you have to understand the mechanism due to which the ocean currents are in existence or due to which the ocean currents are in motion, always understand that you have to keep an account for the wind factor, the permanent wind system, the shape of the coastline, the Coriolis force. Keep in track these things, and you will be able to justify any kind of ocean current. You will be able to understand any kind of ocean current which is in existence in any path. Okay? Now, first of all, here we'll take a look at the Northern Atlantic. Now, what happens in the case of the Northern Atlantic? So, when we talk about Northern Atlantic here, now we do know that due to heating, water level goes slightly higher up in these areas around the equator. Okay. Now, this water is then dragged to the west by the trade winds, both in the northern and the southern hemisphere. This water is continuously dragged to the west. Okay. There is that dragging effect to the west. Now, as the water tends to drag to the west here, the water tends to get dragged to the west here in the western direction here. They will meet or encounter the coastline. And along the shape of the coastline, then they will get diverted. Along the shape of the coastline, then they will get diverted. And then it will be the Coriolis force and then the westerly winds which will take over them. The shape of the coastline provides this directionality. Then you will have the westerly winds and the Coriolis force. Again, Coriolis force in action. Again, Coriolis force in action. Here also, shape of the coastline will push it towards here. Coriolis force in action, Coriolis force in action, and you will have that. Okay? Having said that, how many oceans are there in the world? Are we aware about the number of oceans in the world? Three. Okay. Seven. Okay. Seven. Six. Seven. Seven. Okay. Six. Eight. Eight oceans. Okay. Right. Nine. 4. Okay. 3. Okay. Basically, I don't have, after this answer, I don't have enough capacity to even hit you with a sarcasm. So I won't take that. Basically, there are 5 oceans in the world. You have the Pacific, you have the Atlantic, you have the Indian, you have the Southern Ocean, and you have the Arctic Ocean. These are your 5 oceans of the world. Okay, so Southern Ocean is the ocean surrounding the region of Antarctica. Pacific Ocean, we do know where the Pacific is, in between the region of Asia, Australia, and North South America. Then we do know what is the ocean in between the African region and American region. And you have the Indian Ocean and the Arctic in the north. So, all those of you who basically have said 7, 3, 8, 9, and all these creative figures, do one thing. Today, memorize or try to learn what you did in school. Okay. And try to apportion a blame, that who is to blame for this, that I knew about this incorrect. Is that the school faculty, the curriculum, or God forbid, is it you who had this wrong information? Try to apportion that blame today. So basically, that is the case. And how many continents are there in the world? Okay. At least here we have convergence. Thank you. Good. We have 7 continents. Good. So it is the oceans that we have not concentrated in the school. It is the continents that we have concentrated. Good. At least something is clear. Right. So basically, after reading the answers many times, I wonder where is it that we are going wrong in terms of the school education. And maybe we can have a one-on-one conversation sometime when we are not stressed with these particular modules. Basically, so this is the case of the ocean circulation, the basic ocean circulation in this case. Now let us figure out the same thing in the case of the North Atlantic, and then we'll take a look at it in the region of the South Atlantic. So here, in the region of the North Atlantic, you have accumulation of water here in this region. Now you will have the trade winds. What is the direction of the trade winds? It is like this. Trade winds are like this, isn't it? So these trade winds, they will induce a westward motion here. These will induce a kind of a westward motion here of water. Now this water, when it comes here, the shape of the coastline will divert this to the north, the shape of the coastline will diverge it to the south. But there will be some accumulation of water which is brought here. Some amount of water will be accumulated here. This is something that you can even see in the case of the thermal image. Observe this thermal image carefully. Observe that you have accumulation of water in this area. Right. Now, this is because as the water is being carried here, it is getting diverted in this region, clearly visible. You will have some accumulated water. Now, we do know that the planet is consistently rotating in which direction? Consistently rotating from west to east, right? That is the rotation of the planet. So, due to that rotation of the planet, there is a kind of an inertia provided. And due to that inertia provided, some amount of this accumulated water, it starts to flow back. And that flow back is what we refer to as the counter equatorial current, right? Because it is moving in opposite direction as the north equatorial and the south equatorial current. So that is why you have the accumulated water it flows in the same direction as the rotation of planet Earth, aided by the inertia provided. So that is what you have as a counter equatorial current. Okay. Now, that is what you will observe even in this case. You have the accumulated water. Some amount of that accumulated water tends to flow back in the form of a counter equatorial current, aided by the rotation of the planet and aided by the convergence of the north and the south equatorial current, accumulating some amount of water across the western part of Atlantic. Now here, this north equatorial current further is carried due to the shape of the coastline. And here you will observe that you have the Caribbean islands. The Caribbean islands that you have, Trinidad, Tobago, Jamaica, Bermuda, all these islands that you have, they will end up dividing these ocean currents into two parts. One moves to the north of these islands, other moves to the south of these islands. The one which moves to the south of these islands through the region of Yucatan Peninsula, this is your Yucatan Peninsula, through the region of Yucatan Peninsula, this will enter the Gulf of Mexico. This will enter the Gulf of Mexico and will come out through the region of Florida. This is the state of Florida of US. So that is where it will start to come out, and that is where it is known as the Florida current. It comes out here. It mixes with this particular ocean current which was coming from the north of the Caribbean islands. So combinedly, what will be the volume of water? Very high. What will be the temperature of water? High, because it is combining two warm ocean currents. And then you have one of the most powerful system of warm ocean currents which is generated, which is known as Gulf Stream. Now, why it is known as Gulf Stream is because it is said to be originating from the region. It is coming from the region of Gulf of Mexico. That is why it is regarded as the Gulf Stream. Now, this Gulf Stream, aided by the shape of the coastline and also the Coriolis force, starts bending in the westward direction. Now, meanwhile, here in the northern hemisphere, in the higher latitude, you have cold ocean water which is carried by the wind system. You basically have the cold ocean water carried by the permanent wind, that is the polar easterlies. They start pushing that water. So these polar easterlies, they will push that water near the region of Labrador Sea, and they will form the cold Labrador Ocean current. Very cold Labrador Ocean current. Now this cold Labrador Ocean current mixes with the hot water of this Gulf Stream, and it will create an ideal fishing ground. Wherever and whenever the warm and cold ocean currents meet, it creates very ideal fishing ground because it will increase the amount of oxygen and thereby increasing the proportion of the various small zooplanktons, thereby increasing the proportion of also the fishes. So these are some of the richest fishing grounds of the world where you have the cold and the warm ocean currents meeting, particularly Labrador current and the Gulf Stream. These are your ideal fishing grounds of the world. Regions of, yes, near Newfoundland. Regions of, or regions where cold and warm ocean currents meet, form ideal fishing ground. Of the world. Okay. Furthermore, this Gulf Stream, it slightly cools down, but it is still very, very warm because it is bringing water from the lower latitude to the higher latitude. Then it is carried from west to east with the help of the westerlies. The westerly wind will be carrying it from west to east, and then it is known as the North Atlantic Drift. This is what is known as the North Atlantic Drift. Now, this North Atlantic Drift, it gets divided into different directions in different paths and subpaths. The shape of the coastline, the bottom relief features, one of them goes towards the region of the Scandinavian area, and it is known as the warm Norwegian current, again bringing water from the lower to higher latitude. So it will be the warm Norwegian current. It is this warm Norwegian current also which helps keep that region ice free for most of the year. Right, and this is an area where you have significant amount of fossil fuel deposits in the region of the continental shelf. So you have significant amount of oil drilling also which takes place in the region of the North Sea and so on. So that is where even the economic activities are boosted because of the warm ocean current coming to that region. It moderates the temperature and the climate of that region also. One portion of it enters through the region here, one portion enters through the Bay of Biscay. Some portion of it enters here also into the Mediterranean. Right. So you have classification of the North Atlantic Drift into Irminger current, Rennell current, Norwegian current, etc. But that classification is not required, at least for general studies. You are not required to go into that depth. For your general studies portion, what is sufficient to know is that this Gulf Stream starts turning eastward, is carried by the westerlies, is pushed towards the east, and that movement is the North Atlantic Drift. It then divides into multiple parts owing to the shape of the coastline and also the mid Atlantic ridge in that area. Now, portions go north, portions go straight, and then you will have the most dominant portion getting diverted due to the Coriolis force. And after that, you have the water coming to the lower latitudes. So this water coming to the lower latitudes is being brought from the higher regions. From this higher region, it is being brought to the lower latitude. So that will be a cold current. This moves across the region around Canary Islands to the west coast of Africa, and that is why this is also what is referred to as the cold Canary current. The cold Canary current, as it is known as, and it recirculates the water, right? So you will observe a kind of an entire recirculation of water here. Okay, I will repeat it again. Listen to this carefully once again. So when we talk about these ocean currents, first of all, here you have a kind of a bulge created at the region of equator because of the heating by sun. Solar insolation creates that kind of a height advantage by 8 to 10 centimeter. Then the winds, they start pushing these waters. As the wind starts pushing this water, it starts moving, right? You have the north equatorial current and the south equatorial current. Now they will accumulate some amount of water across the western coast of Atlantic, right? And owing to the rotation of the planet from west to east direction and the accumulation of water, some amount of water starts flowing back in a very weak motion. That is your counter equatorial current. Now, this north equatorial current, if we consider, it is aided by the shape of the coastline in its motion, and then it faces the obstruction by the Caribbean islands. And that is where it gets divided into two portions. One which goes to the north of these Caribbean or Antilles Island, and another one which goes to the south of these islands. Now, the portion which goes to the south of these islands, they will eventually enter the Gulf of Mexico through the region of the Yucatan Peninsula. They will enter the region of Gulf of Mexico. Now, in the region near the state of Florida, that is where they will come out into the Atlantic again. And that is where it is known as Florida current for a brief duration, and for a brief portion, it is also referred to as Florida current. As it enters the Atlantic, then it meets the ocean current coming from the northern portion of the Caribbean islands. Now, together, combinedly, they will accumulate the water. So the amount of water will be very high, and amount of water moving will be high, and also the temperature will be high because you are combining two of the warm ocean currents. That forms one of the strongest and the most intense warm ocean current, that is the Gulf Stream. It is known as the Gulf Stream because it brings the water, it is supposedly bringing the water from the region of Gulf of Mexico. Hence, it is referred to as the Gulf Stream. Now, then, here, meanwhile, in the higher latitudes, you also have the wind system which is moving, the wind system which is blowing. Now, here, ideally, the wind should be moving in the east to west direction because you are talking about polar easterlies. But because you have the islands in such a way, the islands, they shape the movement of water southwards. And that is when you have the cold water of the Labrador, from the region of the Labrador Sea. The cold water comes in around the region of Newfoundland to the northeastern portion of North America. That is where the Labrador current mixes with the Gulf Stream. As it mixes with the Gulf Stream, wherever warm and cold waters meet, there the fish population is very high, and that is where it creates a kind of an ideal fishing ground condition. Meanwhile, this warm water of the Gulf Stream is aided by the westerly movement as it comes further in the eastern side. There it is known as the North Atlantic Drift. North Atlantic Drift, basically the movement in the region of North Atlantic. Now, after that, owing again to the divisions of the coastline, the various different features of the coastline, one portion of the North Atlantic Drift will go between Iceland, right? Another goes across the region around Norway, that is the Norwegian current. Another one enters the region of the North Sea. One of them enters into the Bay of Biscay and comes out. Another portion enters into the Mediterranean. So that North Atlantic Drift gets divided into multiple different parts. As it gets divided into multiple different parts here, then basically the most dominant portion of it will start bending to the right owing to the Coriolis force of action. Now, then again, you are bringing water from the higher to the lower latitude, from the higher to the lower latitude, so that will be colder water. And this colder water moving through the region around Canary Islands to the west coast of Africa will be the cold Canary current. And we have studied earlier also that west coast of the continents will have cold ocean currents, right? So this is basically the case of the entirety of the circulation in the northern Atlantic Ocean, right? So that is basically the case of the ocean currents. Now, what about the region of South Atlantic? I hope this is understood. Now, when we talk about the Southern Atlantic, here in the case of the Southern Sargasso Sea, I will come to the Sargasso Sea. I will come to whatever I am saying. Is that understood? Please pay attention to that. Right? If you have, I understand you have multiple curiosities in your mind. Have patience. I will not leave any portion untouched. I will cover Sargasso Sea as a different topic altogether. The portion that I have said. Now you are concentrating on Sargasso Sea. Now, when we will discuss PYQs, you will have the question, why Canary current is the cold current? What is the counter equatorial current? Why is it that the North Atlantic drift is dividing into three? What is being covered as of now? Have you understood that? Pay attention to that. Okay, at the end of the module, if you feel some portion is not covered, then obviously raise a question. Okay, but please don't start panicking that Sargasso Sea you have not taught, now it will be the end of the world. We will talk about Sargasso Sea. I will show you a different slide talking about what is that Sargasso Sea also. Okay, can we have some amount of patience now? Okay. Sahiti, the cold current of Canary is because here you will observe that the water is being brought from the higher latitude to the lower latitude. Remember, we divide or we classify the ocean current based upon the temperature into warm current or cold current, depending upon what is the temperature of water in comparison to the surrounding areas. What is the temperature of water So basically, if let's suppose we talk about the tropical area, the water temperature can be 24, 25 degrees easy. And when we talk about the water coming from the region of the higher latitudes, it will be slightly cooler, right? So that is where you will have the cold Canary current. Okay. Now, after this, when we talk about the southern Atlantic, in the southern Atlantic, again, a very similar feature will be observed. The difference is here the ocean currents will bend in the leftward direction. Because of the Coriolis force, the ocean currents will bend in the left. So here you observe the south equatorial current, aided by the shape of the coastline and the Coriolis force, they will form the warm Brazil current. The warm Brazil current. But Brazil current is nowhere as strong as the case of the Gulf Stream. Gulf Stream is very, very strong, very intense because the volume of water carried is very high in the case of the Gulf Stream. Now, meanwhile, you will observe here that across the Southern Ocean, one phenomena that you will observe, across the Southern Ocean, you will have the presence of the west wind drift. Across the Southern Ocean, you will have the west wind drift. And that is because in the region of the surrounding areas of Antarctica, you will have the continuous movement of the westerlies across the Southern Ocean. If I can take you back to this slide once again, across this entire region of the Southern Ocean, you will have the westerlies. These westerlies will be continuously moving from a west to east direction. So that is what is going to carry That is what is going to carry the movement of water from west to east. So that is what is going to be observed here. Across the entirety of the Southern Ocean, west wind drift. So wherever it gets the scope, it will start deviating to the left. It will slightly deviate to the left. Okay, wherever it will get an opportunity. Here also it will slightly deviate to the left. Okay, so here again, if I take you back to the slide of the Atlantic, you will observe that this Brazil current encounters a kind of a leftward deviation of this west wind drift, which happens near the Falkland Islands in southern Atlantic, which does take place near the region of the Falkland Islands near the southern Atlantic. Falkland Islands is important geostrategically. If you have read about the Falkland War between UK and Argentina, it is also some of the very unique aspects here. So this is where you have the Falkland Islands, and that is where you have the cold Falkland current. Now, after that, this Brazil current is basically subsumed in the cold west wind drift, aided by the westerlies. And again, it will bend leftward owing to the Coriolis force, and you have the cold Beniguela current. This cold Beniguela current again completes that circulation, and the entire circulation is completed in the southern Atlantic as well. Okay, so that is where, for your examination perspective, you need to be able to you need to be aware of which is a cold ocean current, which is a warm ocean current. And for example, if a random question is asked that which ocean has got the Labrador current, which ocean has got the Venezuela current, you should be able to figure out that whether we are talking about Atlantic, Pacific, Indian Ocean, or so on. Okay, so that kind of a match the following can be observed. There is absence of cold current in the Norwegian region. Yes, you have the North Atlantic drift, which carries it over. That is what is represented in the thermal map. If you observe here, you have this region where the temperature is unusually warm as compared to the same latitude. Why is it so? Because you have the North Atlantic drift eventually turning into the Norwegian current that brings the warm water. Okay, right? Now, uh, please delete red arrow from the Beniguela current. Okay. How these currents are able to retain its temperature even after they have traveled so much of distance in oceans, and so their temperature starts reducing. If let's suppose we are talking about the Gulf Stream will be much warmer here as compared to this region, but still it will be warmer as compared to the surrounding, right? Because the surrounding water temperature is also reducing. It might be reducing with a greater gradient and this is the warm water which is being carried. So it is always in comparison, my dear friend. It is not the case that the Gulf Stream is 35 degrees Celsius here, 35 degrees Celsius here also. No, here it might very well be 15 degrees Celsius, but the surrounding water temperature is much lower. Okay. Counter equatorial current is basically when you have the accumulation of of water of north and south equatorial current across the western margin of the continents, then aided by the spin of the earth from west to east, right, the earth continuously spins in a west to east direction, there is a movement of water in that inertia in that direction, and that is what is observed in the counter equatorial current. That is why across this area, across this entire region, you will also observe a very weak, a kind of a movement of wind pattern, very weak wind movement over this area, right? Very weak wind movement you will observe even on this area. That is what is also sometimes referred to as equatorial westerlies, which you will find in the region of the Atlantic, which you will find in the region of Pacific, but you won't find in the region of Indian Ocean. Okay, and Satyam, Canary Island lies on the subtropical high pressure zone, so it should have diverging winds towards the poles, but still Canary current is flowing against that direction. So understand, Satyam, that diverging wind which you are talking about, there you also have the Azores High which is situated. So it is that divergence which some amount of water is also pushed into the region of Mediterranean, right? It is a kind of an opposition. So water is trying to, let's suppose water is trying to move in this direction. It is the inertia of the movement of water is in this direction. Some wind in this area is also trying to obstruct it, so the water will get obstructed, will get deviated in the immediate vicinity. So it is that divergence which is also responsible for this, but majorly here the trade winds take over, right? And the inertia of water, that is what provides it to the lower portion. Yes, Shalu, that is correct. Rishika, temperature of oceanic current at the top or deep also. We are talking about the temperature of ocean current at the top. Atharv, my dear friend, why and how come this doubt? Ocean currents are horizontal or vertical movement of water. It is a horizontal movement of water, Atharv. How global warming is heating sea? Does it relate to warm current increased circulation? No. The current circulation will get impacted, but the sea surface temperature is rising because of the global warming. What is the reason of the Falkland current, Sham? Basically, you have the west wind drift coming in that area, and in the southern hemisphere, you have a leftward deviation. So that is where in the southern hemisphere, in the region between the Scotia Islands and the Falkland Islands, that is where a weak movement of water happens, and that is where you have the Falkland current. Okay. Chandrajyoti, you had a question about the portion of whether we experience El Nino, La Nina, etc. in this region, in this area. Basically, even in Atlantic, you experience a very weak condition, which is also known as the Atlantic Nino, but it is nowhere as strong as the Walker circulation or the El Nino La Nina condition, or nowhere as strong as circulation as the Indian Ocean dipole, because Atlantic at the region of equator is very narrow. Okay. Where is it that the ocean current is moving upwards and downwards? Please don't tell me that you think that this is the sea surface and this is the bottom of the ocean. Please tell me that is not the conception that you are having, that this is the top of the sea surface and this is the bottom of the ocean. I hope we are not having that kind of a confusion. No? Atharv, is that the confusion that we are having? No. Okay. Then where is it that the water is moving upward and downward? Are you talking about thermohaline circulation? Thermohaline circulation is different. This is a different portion. Thermohaline circulation, some part of it is included here also. but this is a different circulation. Here on the surface, the water is moving from the tropics to the region of the higher latitude, and from the higher latitude to the lower latitude, from the lower latitude to the higher latitude, from the higher latitude to the lower latitude. So that was the confusion. Okay. You thought when I am saying that the water is going here. Oh my God. Okay. I hope that is understood now. Good. Shanawaz, send a mail. Reminder on the mail. I have seen your previous mail. Send a reminder on the mail and we'll get in touch. Mixing of Brazil current and Falkland current will also create fishing ground, yes, but because this is not as strong as the Gulf Stream and the Labrador, that is why it will not be as strong. Okay. Now you observe a similar mechanism at play in the Pacific also, absolutely similar mechanism. Now here also you will find that the warm water tends to get warm water will expand, or the water in the region of equator will tend to expand ever so slightly, and that expansion of water aided by the wind movement will initiate the movement of water. So here also you will have north equatorial current and a south equatorial current, and here also in the case of the islands, here you will have some accumulation aided by the movement of Earth, the rotation of planet from west to east. Some amount of that water will start to flow back. Some amount of that water will start to flow back, and that is what we refer to as the counter equatorial current. So remember guys, why is there a counter equatorial current? Had there not been an accumulation of water, there would not have been a counter equatorial current. Why it is known as counter equatorial? Because its direction is opposite to what you observe in north and south equatorial current. Its direction is completely reversed. Now, it is aided by the rotation of planet from a west to east direction. That is what aids the motion of the current from west to east. Then further here, as the north equatorial current further starts bending to the right owing to the Coriolis force, you have the Tsushima current to the east portion of Japan, and you have the Kuroshio current, Tsushima to the west and Kuroshio to the eastern portion. Now here, just like the Labrador current, you have the cold Oyashio current, which meets with the Kuroshio current. This is also a very good, very strong fishing ground. Very ideal fishing ground. Okay, this also ends up creating one of the most ideal fishing ground that you will see. And then after that, as this ocean current tends to move, basically carried by the westerlies, you have the North Pacific current. It is carried by the westerlies from west to east direction. And because you have the obstruction in the form of North American continent, here it will also basically get divided and bifurcated into two. So here also you will observe that it is bifurcated into two, but then this Alaska current is carrying the water from the lower latitude to the higher latitude. So it can be regarded as a warm current. California current is going to carry water from the higher to the lower latitude. So it is going to be cold current. Right. Now, in this entire circulation that you would have observed, even in the case of Atlantic, even in the case of Pacific, you would have observed this phenomena that all around the margins between the continents and the oceans, across the margins, you will have the movement of water in a set direction, in a certain direction, aided by the wind movement, the westerlies, the trade winds, etc. Now, across the margins as the water moves, if you can imagine that scenario, let's suppose this is the margin. The water moves here. Some water will be dragged here also. Some water will be dragged here also. So in the central position, you will have a water movement like this, a small water movement, right, in a circular motion. A kind of a small movement like this, like this, right? These are referred to as gyres. These are referred to as gyres. which is a kind of a circular motion, because all around it, as the water is circulating, it will impact the central portion also, where you will have this small circulatory, like a whirlpool system, but obviously in a much larger scale, you have a circular movement of water. That is what is a gyre. Now, when we talk about the southern Pacific, in the southern Pacific, the south equatorial current, it bends to the left, and again, aided by the shape of the coastline, you have the East Australia current. One weak ocean current enters into the Indian Ocean from this region, what is also regarded as the Lewin current. This is also regarded as the Lewin current. It basically provides water, some amount of water from the Pacific into the Indian Ocean. Now, this East Australia current then again will bend to the left in the form of the cold west wind drift. It will mix with that. The cold west wind drift, just like you had the Venezuela current in the Atlantic, here you will have the Peru current or the Humboldt current. This is what is also known as the Humboldt current. Okay, and the entire circulation is completed. So this mechanism of the Pacific is absolutely almost similar in terms of the working principle as you compare it to the Atlantic Ocean. But things change when we come over to the Indian Ocean. Over the Indian Ocean, the things are drastically different. When we talk about the Indian Ocean, it is different. Why? Because as you can see, in comparison to the images of the Atlantic and in comparison to the images of the Pacific, northern portion of Indian Ocean is closed by landmass. It is closed by landmass. Right. So, northern Indian Ocean is so very small, surrounded by landmass. The influence of wind pattern in the northern Indian Ocean is much more prominent. Okay. Northern Indian Ocean being small and surrounded by land, experiences greater impact of wind. Greater impact of wind motion. Now, we do know that in the case of the northern Indian Ocean, that is over the Indian subcontinent, there is a shifting of the ITCZ which regularly happens. Now, due to that shifting of the ITCZ, the wind pattern also is prone to change. Right. Now, during the conditions or during the months of, let's suppose, if I write it here, the months of summer or the months of advancing monsoon, the southwest monsoon, and the month of northeast monsoon, the wind systems and the wind patterns, they revert themselves. During the southwest monsoon, what is the direction of the wind movement? This is your direction of the wind movement, isn't it? So that is why even here you will observe that in the northern Indian Ocean, the ocean currents, they move in a kind of a clockwise direction, aided by the wind motion. Aided by the wind motion, they move in a certain direction. But when we talk about the retreat monsoon and the time of the withdrawal of the northeast monsoon, the wind direction right now, presently, what is the wind direction? Wind direction is like this. Right. So that is when you observe that there is a reversal in the ocean current direction, and that is because of the direction of the wind. So this is the case where in the northern Indian Ocean, you will have a complete reversal. Now, in this case, when we are talking about the northeast monsoon situation, this will supply more water across the western coast of Indian Ocean. And the south equatorial current will also supply water, accumulate water in the western coast of Indian Ocean. So that is where in these months you will observe or experience the counter equatorial current. But that counter equatorial current will not be so very prominent during the summer months. That is where you will find that the direction of the water is different altogether. So counter equatorial current is not very predominant. Here the counter equatorial will still be observed. When we talk about the southern Indian Ocean, in the southern Indian Ocean, again around the region of Madagascar, you have the ocean currents getting bifurcated. You have the Mozambique current, you have the Agulhas current, again mixing with the west wind drift. Here, observe the Leuven current that I told you. And here you have the Australia current, the West Australia cold current, which comes into the picture, and you have the entire circulation, which is thereby completed. Okay, so that is basically the ocean current and its movement in all the three oceans. What kind of questions have been asked from here? Majorly, the questions which have been asked are in the tune of what are the ocean currents, what are the impact of, or what are the forces which lead to the formation of ocean currents. That is the major question, right? You also had questions that how important is wind in terms of the generation of the ocean currents. Why is it that the winds are influential in generation of the ocean currents? Elaborate with the help of the example of northern Indian Ocean. Then you have sometimes the questions which is asked, what are the forces responsible for the generation of ocean currents? Elaborate with the example of Atlantic Ocean. So such kind of questions where you have to draw the diagram, you have to talk about which are these ocean currents in existence. Now we come to the Atlantic meridional overturning circulation. This is also a kind of an oceanic circulation in place. Now this is an oceanic circulation where you will observe that oceanic water across all the major oceans, they end up mixing with each other. They end up interacting with each other, and they end up circulating amongst each other. Right? So here, from the lower latitudes, as we had seen yesterday also, in the lower latitudes, and this is a factor of thermohaline circulation, works on mechanism of thermohaline circulations. Okay. So in the case of the thermohaline circulations, what did we observe? That warm water is carried over to the colder areas where they lose their temperature, become very cold. When they become very cold, they become dense and they start sinking. And the subsurface water then moves. It can rise up. In the lower latitude, it can get heated up or rise up, or it can move over and there can be a kind of a circulation. Right? So that is where on the surface you will have warm water flow, and in the subsurface you have the cold water which will circulate. Now this is a part of what is also known as the global conveyor belt. This entire circulation is a part of what is known as global conveyor belt. I hope we are aware about the phenomena of a conveyor belt or what is a conveyor belt. You would have seen it in the uh, flour mills, or let's suppose in escalators, walkways also, where you have a rolling system where it is circulated, right? This is what you would have observed. That is a conveyor belt. Now, here, this is also what is known as the global conveyor belt because across the world's ocean, you have this circulation which does take place. Now, in the portion of the Atlantic, if we observe this circulation in the region of the Atlantic, one of the most prominent warm water currents in the Atlantic is the Gulf Stream. So this is representative of the Gulf Stream, even though it is a schematic representation. So don't worry about the fact that in the image you had shown Gulf Stream here, here you are showing it in the middle. No, it is just a kind of a representation that warm water is getting carried to the higher latitude and it overturns. It goes to the higher latitude, it overturns, and then moves as a subsurface current. Hence, Atlantic meridional, meridian, meridional overturning circulation. Okay, so this basically is very important in order to distribute heat from one part of the ocean to another. Generally, all the excess heat or the surplus heat accumulated in the lower latitude is distributed in the higher latitude with the help of this kind of a circulation. And also, you observe distribution of nutrients, etc., being carried over by this kind of a circulation. Okay, so that is basically the characteristic feature of it. So, global conveyor belt is a system of ocean currents that transport water around the world. While wind primarily propels the surface currents, deep currents are driven by difference in water densities in a process called thermohaline circulation. Now, density depends both on temperature and salinity of the water. Along this conveyor belt, heat and nutrients they move across a leisure 1,000-year cycle. That means to complete the entire cycle, it will take a time of 1,000 years. We have only been observing this thermohaline or this global conveyor belt for the past couple of or past few decades, right? But we are able to think about or we are able to simulate that what would have been the motion in general. Now, the Gulf Stream is part of the Atlantic meridional overturning circulation. As the warm Gulf water approaches the North Atlantic, it cools, releasing its heat into the atmosphere. As it cools, water becomes salty and dense and hence sinks or overturns at the bottom of the ocean. The Gulf Stream and AMOC are a part of the larger process of thermohaline circulation, often nicknamed the ocean conveyor belt. Okay, so that is the part of the ocean conveyor belt. It describes the interaction of surface currents like the Gulf Stream with the deep, slow moving underwater currents initiated by the thermohaline circulation. These interactions, the impact of it, mix ocean water, salts, and even organisms on a large global scale. As ocean temperature and density contribute to temperature change in the atmosphere, ocean conveyor belt also contributes to the climatic variations across the planet. Okay, now here, when we talk about this ocean conveyor belt, this is in news, this has been in news recently in terms of AMOC in particular. And the news has been that global warming impacts the AMOC, right? Global warming impacts AMOC. How? So, when we encounter the conditions of global warming, sea surface temperature across the lower and the higher latitudes, everywhere, the sea surface temperature is rising up, isn't it? Everywhere, the sea surface temperature is rising up. So, here, when we talk about it, yes, Rohit, perfect. So, when we talk about it, from the lower latitudes, the water is moving. The water is moving. But across the higher latitudes, where the water should ideally cool down and should overturn, because the sea surface temperature in higher latitude is also significantly higher now, that overturning is not happening anymore. Right? So, due to global warming, overturning doesn't happen easily as water temperature in higher latitudes is increasing. Is increasing. So as a result of that, this entire motion of AMOC, it slows down. That means the same water will be present in the same region for a longer duration of time. When the water is present in the same region for a longer duration of time means what? means it will be exposed to greater amount of heating. Let's suppose if the water is continuously moving, that heat will be distributed. But if all that water is stagnant in the same region, it continues to heat, what atmospheric phenomena can be initiated as a consequence of this? Beautiful, Shazia. Very good. Shyam, correct. Ziba, correct. Everyone. It is basically cyclonic conditions which can be initiated. That is why the region of North Atlantic in the past few years has been experiencing very frequent frontal formation, very frequent cyclonic formation has been observed in the region of North Atlantic. Very significant number of storms have hit the region of North Atlantic, making the climate in that area unpredictable. Now, coming to the effects of ocean current. What are the overall impacts of ocean current? First of all, ocean currents, they will influence the temperature of a region. We have discussed that in temperature distribution. Influences temperature, the temperature of an area. Okay. It can heat up an area, it can cool down the region also. So that is where the temperature of an area is impacted. Now, the mixing of warm and cold ocean currents help to replenish the oxygen and favor the growth of planktons, the primary food for the fish population. The best fishing grounds of the world exist mainly in these zones where you have the warm and the cold oceanic water mixing with each other. Now, other than that, where you have warm and cold oceanic water mixing, above it, you will also have the mixing of warm and cold air. So that also creates fog, right? You will have warm air undergoing condensation. So significant amount of sea fog gets created. So regions here also experiences intense fog formation in the area. Intense fog formation is observed or is experienced in that area. Now then, cold ocean currents, they are responsible for the creation of deserts across the western margin of continents. Why is it the case? Why is it so that the cold ocean currents are responsible for the creation of deserts? Basically, yes, fog is very bad for navigation. It is a nightmare for navigation. Yes, Ziba, correct. So think about it. If let's suppose this is a land area here, if this is the land area, and here you have the water, which becomes very, very cold. You have the cold water. Now, cold water in a local region can create a kind of a high pressure, but this will also cool the air above here. The air will get abnormally colder, isn't it? You will have colder air in this region. And sometimes what happens is that you have warmer air above. Warmer air above that. So this is a condition of temperature inversion. This is a condition of inversion of temperature. Leads to inversion of temperature and lack of rains. That is why across the western margin of the continents, be it in South America, you observe the Atacama Desert, be it in the northern America, you will observe the presence of the Mojave Desert, be it in the region of Africa, where you have the cold Beniguela current, you will observe the Kalahari Desert, be it in Australia, where you will have the West Australia current, you have the Victoria Desert. Does not mean that you start associating every ocean current with a desert. Few deserts are created in the subtropical region also. It is not because that don't start linking it with the formation of Thar Desert, etc. It has got nothing to do with it. Okay, so Atacama, Kalahari, Victoria Desert, these are the examples of desert on the western margin. Okay, yes, Pranay, that is correct. So that is basically the effect of ocean currents. And now we come to the portion of Sargasso Sea. So one of you had been persistently following that Sargasso Sea, Sargasso Sea. So I think it was Seema. Seema, now is the time to pay attention. Sargasso Sea. So what is this Sargasso Sea? What is this phenomena? So basically, when you had the Portuguese explorers, the Portuguese sailors who were navigating the Atlantic early, way early in the 1400s and the 1500s, they encountered a zone of absolute calm condition. And the zone of absolute calm condition where you had a lot of this brownish seaweed, significant amount of this brownish seaweed. Now, in Portuguese, this seaweed is what is also referred to as sargassum. It is known as sargassum in Portuguese. Now, this region where you had a lot of this seaweed, it would be significantly rich with biodiversity. Lot of biodiversity to be found in that area. Obviously, you will have the plant species, animal species, etc. coming to that area. Lot of biodiversity. But then it would be a nightmare for the ships, because oftentimes these very long and interconnected seaweeds would get entangled in the hull of the ships. Even in the modern day and ages, it still proves to be a nightmare for shipping, because basically the propeller of the ships, many of the times in these propellers, you have the seaweed which attaches itself and the propeller can't function anymore. So that is basically where you have this region of Sargasso, which is known as Sargasso Sea. But how is this Sargasso Sea created? Why is there a Sargasso Sea? So basically, you will observe here, this lies in the region of the subtropical high pressure. So that subtropical high pressure is responsible for a zone of absolute calm, the zone of no movement. That is basically observed in this area. So you don't have much of a wind movement in this area. To add on to the fact, all around it, you have motion of ocean current. So this ocean current, let's suppose it is moving like this, it will initiate some motion of the water here also, some motion of water here also. But as you move farther away, there will be no motion initiated by that ocean current. Similarly, if the ocean current is like this, some motion of water here also, some motion of water here also, but no movement of water here. Similarly, here also. So Sargasso Sea is the only sea across the world which, rather than being surrounded by land masses, is surrounded by ocean currents. To the south, it has the North Equatorial Current. To the west, it has the Gulf Stream. To the north, it has the North Atlantic Drift. And to the east, it has the presence of Canary Current. All these various different currents, all these various different circulations, they give rise to the presence of the Sargasso Sea. Okay, so Sargasso Sea is very, very rich in terms of the seaweed, the brownish seaweed which covers the surface, but significantly is a nightmare for the shipping and the navigation industry. And it is created as the ocean currents, they circulate in a certain direction. In the central portion, they won't have much of an impact. So here you have a zone of an absolute calm, right? Okay. No, whirlpool is something on a very short area. This is a large area that we are talking about. You have other fundamentals behind it also, that is the formation of an Ekman spiral and the Ekman transport. But I don't want to lead you into that area, because again, This will create so much amount of confusion beyond reckoning. But just understand that water, when it moves, let's suppose the water is moving here at the depth, at a slightly lower position, water will move slightly lower and slightly divergent. Then again, at a lower position, water will move slightly divergent, slightly here. So, but anyways, that is the Ekman spiral and Ekman transport. I don't want you to get into. So that is basically why you have in this entire zone a zone of calm. When you have a zone of calm, obviously seaweeds will naturally grow in that area. Okay. Satyam, don't worry what the Gulf Stream is indicated here. Gulf Stream is a warm ocean current. Okay. Shyam, why Sargasso Sea is present in Atlantic but not in Pacific? That is because in the region of the Atlantic has that adequately perfect size where you can have one complete gyre kind of a movement covering the entire ocean with not much disturbance at the center. When you observe the region of the Pacific, you have two small gyres which get formed, right? The West Pacific gyre and the East Pacific gyre. So that is why, because of that small gyres which get created, you don't have that zone of non-disturbance. Okay, so that is basically the case of the Sargasso Sea, why it is not present in the Pacific Ocean. It is like a river because in middle of the river speed of water is high, but on the edge it is lower. Yes, if you think about the ocean currents in terms of its movement, yes, Seema, that will be correct assumption. That just like here, the ocean current will be maximum speed here, its speed will reduce, its speed will reduce, its speed will further reduce. So that is one of the aspect of it. The other aspect is also about the fact that if you can imagine it like that, just for, if you are unable to understand it, fair enough. Forget, erase it from your memory. If you are able to imagine it, think about it as a surface of water. This as a surface of water. Now, on top, the winds are carrying it. The winds are basically providing that deviation. On the lower portion, the water will be carried. It will be deviated ever so slightly like this. In the lower portion, the wind will be, or the impact will be even lesser. Drag of water will be even lesser. And there will be a slight deviation like this. In the further lower portion, deviation will be like this. So from the upper portion, which was like this, the lower portion has got a deviation like this. So that is why you have a kind of a spiral, non-disturbed water column, which is created in the central portion. And that spiral, non-disturbed water column is where you will generally find all around it the circulation is happening, the central position, undisturbed, slightly higher water level, and that is where the seaweeds will grow. But anyways, that is about the Sargasso Sea. Okay. The reason why you don't have Sargasso Sea in the region of the Pacific is because in the Pacific here you will observe, you will have two formation of these gyres, circulatory motion of the gyres. That is why you don't have any area which is undisturbed. Whereas in the case of the Atlantic, it is actually adequately in size. See, Sargasso Sea is not even observed in southern Atlantic, not in southern Indian Ocean. Here only, because it is adequately fitting in size and the power of these ocean currents are just adequate to create a large ocean current or large ocean region surrounded by the currents from all sides, right? You don't have that undisturbed zone created in other areas. Okay. Yes, it is in this region where the very defamed Bermuda Triangle also ends up lying. It is in that area only. Sargasso is also created by a gyre, right? Now, after this, Garam Pani Ka Chashma in Sona in Haryana, example of warm current. See, I'm intrigued about what is Garam Pani Ka Chashma, but it is not the warm ocean current that we have talked about. I hope you are not talking about the mirages which get created, but I am very, very intrigued to know what this Garam Pani Ka Chashma in Sona is. So Sona is the region in the outskirts of Gurgaon, if I'm not mistaken. I don't recall the last time I went to Sona. I don't recall any large water body there. So what kind of a garam pani ka chashma are we talking about? I'd be very, very interested to know that. So let me know whenever you get time. Do let me know what is that. I hope you are not talking about the mirages. If you're talking about the formation of mirages, that will be a massive letdown because now I'm very, very intrigued and very curious that what that garam pani ka chashma is. Okay. So now we come to the portion of the coral reefs. Corals are basically something, coral reefs are, this is the portion that you will cover if you have not already covered in significant detail in the portion of environment ecology as well, right? You will cover that about cold water, warm water corals, coral bleaching, the zooxanthellae, symbiotic relationship of the corals and the algae. How many of you have covered that in the portion of environment ecology? How many of us have covered that? We have covered it. Okay, okay. Many of you have not attended the environment. Okay, fair enough. When you will attend it, whenever you will attend it, so wherever you will attend it, whosoever will be covering it, you will cover it in detail. So here we are going to cover the portion of corals from a purely geographical perspective. That is where these corals grow and what. First of all, many of us, we are not aware about what these corals are. When we take a look at these vivid color patterns on the underwater region, underwater world, many of us, we are not aware that these are basically the corals. These, all that you see, that is basically the corals. So many of us, we are not aware that what they are. Are they plants or animals? So the entire structure that you see, it is a combination of many of these corals taken together. Individual coral is known as a coral polyp. Individually, it is a coral polyp. That is an animal. Okay, it is not a plant. It is an animal having tentacles affixed to it, and it has got a calcium carbonate exoskeleton which affixes them onto the ground surface. So that is where which fixes them to the ground surface. Then this vivid coloration pattern that you see, corals generally, when you consider the individual corals as animals, they are made up of calcium carbonate, right? That is what is the main constitution. It is the calcium carbonate. So calcium carbonate is whitish in structure, very white, pale white. But then you have in these corals the habitations of an algal species of zooxanthellae, which basically is in a mutually beneficial relationship with a coral. And that mutually beneficial relationship will benefit the algae also because the corals provide them a surface to grow and the nutrients. And the algae manufactures food by photosynthesis and gives food to corals. It is that algae which provides oxygen also into the oceanic water, and it is that algae which basically also provides that coloration pattern to the corals. Okay, so these corals, they are very, very important for the marine ecosystem because they provide shelter to a large variety of species underwater. Many of the times they are also akin or similarized to the condition of tropical rainforest on the planet, on the land surface. Just like tropical rainforest enrich the atmosphere with oxygen, these coral reefs, with the help of the zooxanthellae, they enrich the water with oxygen. Just like the tropical rainforest are able to support a large amount of population of species, here also very large amount of population of species are supported by these corals. Now this algae, it carries out the process of photosynthesis. So this process of photosynthesis will be carried on when or where? Where the sunlight is available, isn't it? Till the portion where the sunlight is available. That is why majority of the coral reefs, you will find to be present and persistent in the region of continental shelf area. Okay, so a coral reef is an underwater ecosystem characterized by reef building corals. Reefs are formed of colonies of coral polyps held together by calcium carbonate. Carbonate ions, calcium ions, which are present in the oceanic water, that is assimilated to form that calcium carbonate. Most coral reefs are built from the stony corals whose polyps do cluster in groups. The largest coral reef is the Great Barrier Reef, which spans across 1600 miles, that is 2600 kilometers, of the northeast coast of Australia. It is so very large and huge, it can be seen even from space. Okay, with that, we'll end the session here today. Tomorrow, when we meet, we'll talk about the growth of these corals and basically how they grow and how they create coral islands. We'll be discussing about the types of these corals in terms of the location. You have the fringing reef, barrier reef, you have the various different types of atolls which get created. And then we'll move over to the portion of Indian geography. Now, in Indian geography, we'll form a unique approach for Indian geography, which you generally don't find in the case of the books. We are going to talk about the origin of different places in India. We have already talked about the origin of Himalayas, for example. In the portion of geomorphology, we have discussed how Himalayas came into existence. We'll talk about how the northern plains came into existence, how the peninsular plateau came into existence, how the Deccan Trap came into existence, how the Thar Desert came into existence, how the region of Andaman Nicobar came into existence, how Lakshadweep. Lakshadweep is something that we will study in the portion of coral reefs itself. So that is where we'll carry on from tomorrow. Okay, so that is where we leave the session today. And Seema, are we not very behind in the modules? To be very precise, we are very, very behind in the terms of the modules, but it hardly matters, my dear friend. Please don't think about that when we are going to, are we going as per time or not? Are you able to understand everything or not? 5 months down the line, 1 year down the line, when you are appearing for the examination, I don't think it will matter to you whether the portion was completed exactly bang on time or whether we had to take an extra class. This Saturday, we will take an extra class. But what will be important, very important, is whether the concepts that we have put so much attention on, we have moved very slowly over the concepts of climatology, geomorphology, and even oceanography. We have moved very slowly over that. The aspect has been, the basic endeavor has been so that you understand. So, as long as that is fulfilled, I don't care about anything else. And funny, I did not understand how contour bulge is formed in the tide. So it is basically the gravitational pull of the moon or the sun creates a bulge on one side, right? Now think about it, that the planet is rotating. It is a rotating object. Can it rotate easily? Well, can an object which appears to be like this, in terms of including the bulge, can it continue to rotate easily? Well, no. So, for the conservation of momentum and for the balance of the inertia, that is where the water develops a bulge on the other side also. That is why the counter bulge. And what is Somali current and how it affects the monsoon? Somali current is a small oceanic current which basically is generated due to during the time of the southwest monsoon from the region of Horn of Africa towards the region of the Arabian Sea. It is not a very strong current, but nonetheless, when you have the Somali current along with the temporary Somali jet stream, which is also the Finlater jet stream, basically it pushes more winds towards the towards the Indian subcontinent, bringing about an abundantly more rainfall. Okay, and irrigation and cropping pattern will be taught in geography. Yes. Uh, then Sham, please give me some tips how to stay focused on for a long time. That is basically going to happen. Your focus or your attention is largely going to be dependent upon whether you are interested enough or not, right? If you are, and I will say with utmost honesty and as much as experience I can bring to the table, we have candidates, for example, when they will approach climatology, the prime thought will be, tell me about monsoon, tell me about cyclone, rest of the things I'm not at all interested in. When they will study the portion of economy, for example, they would have heard about repo rate has been increased, reduced. They will simply go about, tell me about repo and reverse repo, and take all the MCLR, etc. features with you. I'm not in. So if you lose interest at any point of time, you will never be able to concentrate. As long as you are interested and curious enough to know the reasons behind why is it that UPSC wants you to study these things. All these things help you understand the world around you better. All these things help you understand India better. Think about it. UPSC is not asking you to study about the Heisenberg principle or the Schrodinger's equation. UPSC is not asking you to solve the Fourier equation or the Laplace theorem. No. UPSC is asking you to study the area, the topics which are influencing the world around you. Be curious about the world. There is no reason why you won't be interested anymore. But if you take it as a zero sum game, that this topic, if there was a previous year question only, then I will study, otherwise not. That doesn't work. It might not work. It is a kind of a lottery. Then you won't be able to concentrate. And Sulakshana, for 2024, how to approach environment ecology, should we depend on current affairs? Along with the static portion, the current affairs will be more than sufficient. Yes. And on that image, is global conveyor belt part of it in Atlantic Ocean as AMOC? Yes, Shahrukh, that is correct. Okay. Siddhant, see, pay attention to the graduation as of now. That needs to be completed. Current affairs need to be covered. Current affairs you cannot ignore. And one GS if it is not too much of a stress. Athar, will you teach environment also? Mostly yes, if the time permits, if the schedule allows. Okay, so that is where we'll leave the session here today. We meet again tomorrow. Phytoplankton is an algae. It is algal species which carries out photosynthesis. It is a kind of a plant. Okay, we meet again tomorrow where we continue further and enter into the portion of Indian geography. Till that point of time, if possible, try to revise, but come back tomorrow refreshed. Do take care of yourself. Goodbye. Thank you.